So here to help us start our webinar is Dr. Tracy Wegner, our program chair of the Tropical Conservation Biology and Environmental Science program at Hilo and professor of marine science. Dr. Tracy Wegner is an aquatic biogeochemist whose work looks at factors of water quality and biochemical cycling. And many students agree that she's great at meeting students where they are. She's incredibly understanding and teaches in a way that takes very complicated concepts and makes them so that anybody can understand them. So we're really thrilled to have her here with us today. Thank you, Dr. Wegner, for being here. And I'm gonna hand it over to you. Mahalo.
Sorry, I'm having technical difficulties. Would it be possible for you guys to do the slides?
Hi, Tracy. Yeah, we can see your slides. If you put it in full screen mode, we'll be able to see it.
Yeah, it just covers my other screen up. That's what's the issue.
There you go.
Do you see the full slide now, or do you see the side panel as well?
We can see the side panel, but you know what? If you want to do it that way too, can.
It's really bizarre. Okay, I'll just do it with the side panel. That makes it easier for me anyway. Well, aloha, I como mai. As director of the Tropical Conservation, Biology, and Environmental Science graduate program at the University of Hawaii at Hilo, I am very pleased to welcome you to the Spring 2021 Zoom TCBES Symposium. This is the first time we have ever held our symposium this way. But before we begin with our extraordinary program, I would like to tell you a little bit about TCBES. Our mission is to provide a Master's of Science level graduate education that fosters the knowledge and techniques in conservation biology and environmental sciences, including basic, applied, and socio-ecological research, as well as promotes scholarly activities in marine and terrestrial environments that will enable participants to pursue careers in research and natural resource management. The program utilizes the extraordinary biological, physical, and cultural complexity of the island of Hawaii as a focus of investigation and study. Graduates of this program are highly successful in obtaining technical positions as scientists, resource managers, and educators, as well as admission into PhD programs in related fields. If you would like to learn more about our program, I invite you to check out our website. Here is the address below at the bottom of this slide. The program began in 2004, and we've had over 200 graduates since then. We currently have 45 faculty associated with the program across 5 different colleges at Hilo. We also have numerous affiliated and adjunct faculty, as well as mentors associated with our program, and we want to send out a huge mahalo to those folks. These are professionals who are serving as mentors for student internship projects, on students' thesis committees, teaching classes, and giving seminars. A huge debt of gratitude goes to them, and we welcome their continued partnership. In the TCBES program, there are 2 tracks. The first that I'll speak about is the thesis track. The thesis track prepares graduates for technical positions and for entry into PhD programs in related fields. Students conduct original research guided by a UH-Hilo faculty advisor. Students form a thesis committee of 3 or more members who contain expertise on their research topic. Students are required to write a research proposal and defend that before they complete their research. Students often use the amazing natural environments of Hawaii Island, and most projects contain a mix of field and laboratory research. Our students take advantage of the many shared resources across the UH-Hilo campus, including the Analytical Lab, the Spatial Data Analysis and Visualization Lab, the Core Genomics Facility, the Pacific Aquaculture and Coastal Research Center, the Listening Observatory for Hawaiian Ecosystems Lab, the Hawaii Cooperative Fisheries Research Unit, and more. Students do a defense of their thesis as a public presentation, and starting last year, you can now find all of these on the TCBES YouTube channel. The second track that we have in TCBES is the professional internship track. In fall of 2018, we expanded our internship track into a professional master's. The students in this track do over 600 hours of internship work in an immersive experience. In the past, the majority of UH-Hilo TCBES graduates followed the thesis track, received an excellent education, and then many of them went into working as natural resource managers rather than continuing their education and obtaining a doctorate. With this reality in mind, UH-Hilo revamped the internship track option to align courses with the knowledge and experiences a graduate needs to actively contribute as a scientific professional in a local, state, or national environmental conservation agency, an NGO, and other organizations. Many of our students work on Hawaii Island, but the professional internship can happen anywhere in the world. We work with agencies to create a professional internship project for each student that moves one forward in achieving professional goals while also being of benefit to the host agency. This process begins with the graduate student defining their interest. We ask, what are your scientific wonderings? What are your drivers? How do you want to contribute to the greater good? The graduate students figure out those answers and rise up to the challenge of conducting their professional internship, providing deliverables to their agency, and writing a compendious report for the TCBES program that is housed in Hoku, the University of Hawaii at Hilo Institutional Repository. Also note, the TCBES theses are also housed here as well. Graduating students in the professional internship track give a public presentation of their rigorous internship project. And you can join us on May 6th to hear more about their experiences. If you can't make it, that's okay. You can watch that also on our TCBES YouTube channel. Now, a little bit about our symposium. It is put on annually. It is planned, organized, and run by the graduate students. They do everything from inviting and hosting the keynote speakers, building the program, organizing catering and rooms, well, not this year, but maybe hopefully next year, and to all the behind the scenes last minute scrambling of things that you don't know and probably don't want to know. Last year, the symposium was canceled last minute as we went into lockdown following spring break due to the COVID-19 pandemic. But we are back and better this year in a new format that our world has embraced due to our current conditions, Zoom. And while Zoom might seem impersonal, through this medium, more people have attended the TCBES seminars than ever before, reaching an even broader audience. So while we can't be in person, more people are able to attend. So I want you to check out some of our pictures of our most recent cohorts. This is 2020, and you can see it's a little bit different than before. Here is a screenshot of us all on Zoom in one of the TCBES core classes. This is a picture of the 2019 cohort. Here we were still in the field at that time. As you can see, typical Hilo weather up on the Saddle Road. And then I circled our event coordinators for today. So please give them a large mahalo. This is Carmelita Villalobos, Lisa Mason, and Jordan Anderson, as well as Becky Ostertag, who oversees the Matters Club. I'd also like to thank Kapuka and Kuma Kekoa Harmon for our opening Kipaipai, our keynote speaker, Christian Jardina, and Halau Ohia team for designing and leading the Kuahu workshop that will shortly follow after this introduction. And mahalo to all of our presenters yesterday and today. So welcome to the TCBES Symposium. Mahalo.
Mahalo, Tracy, for your opening remarks. And right now we are going to be moving into our next session, which is our Kuahu session, building a foundation and setting intentions. This workshop-like session is an interactive opportunity for us to learn about a cultural practice called Kuahu, and this is being hosted by our friends at Halau Ohia. So next slide, please. Right now, what we're going to ask is that if you are wanting to attend this session, that you leave this webinar and log into our external Zoom room. This room is being hosted by our Halau Ohia Alakai. You're going to be using the meeting ID here on the screen and entering the passcode Kuahu. We're going to be admitting people right now at about 9:15 and closing admittance at 9:20. So you're going to want to leave this webinar and log into Zoom using this information. If you have any questions, you can put it in the Q&A box and we'll try to get you an answer as soon as possible. See you there.
Aloha, everyone. We're going to give everyone just 2 more minutes to get back into our session. We ended our last session just a little bit behind. So we're going to give everyone 2 more minutes to get in. So we're just going to be pushed back just a few minutes. Thank you. All right, everyone, looks like we're ready to get started with our 3rd session. So this is day 2. We want to welcome everybody to our TCBES Symposium. Again, we just want to remind everyone that you are muted and your videos are turned off. But if you want to communicate with us and ask questions at any time, just throw them into the question and answer box and we will relay those to our speakers at the time. If you are speaking, we will promote you to a panelist so that we are able to see you and to hear you while you are presenting. Remember not to turn on your video or unmute yourself until I announce your name. All right, and with that, first up, we have Dr. Tracy Wegener, who is a professor of marine science and the chair of the TCBES program. Tracy, are you ready to get started?
Sure. Thank you for having me here today. Oh, next slide. Coral reefs are one of the most biologically diverse ecosystems on Earth, providing billions of dollars in jobs, food, recreation, coastal protection, and other valuable services. In Hawaii alone, coral reefs contribute $800 million annually to the state's economy. Coral reefs are also culturally important. In the Kumulipu, the Hawaiian creation story, it starts with the formation of a coral polyp. Next slide. But coral reefs are under threat from sewage pollution, which poses not only a threat to the reefs, but also to human health. Through the release of pathogens, nutrients, cleaning chemicals, and hydrocarbons. Some of the human health threats include abdominal, skin, urinary, and blood infections. Ecological effects include shifts from a coral to a seaweed-dominated reef and eutrophication, as well as declines in coral and reef fish abundances, increased prevalence and severity of coral and reef biota disease and infection. Next slide. But here in Hawaii, coral reefs are being impacted by sewage, primarily through a diffuse, widespread source, cesspools. These are the most commonly used domestic wastewater depositories in Hawaii, and they are used here more than in any other state in the nation. Hawaii Department of Health estimates that there are presently 90,000 cesspools statewide, with 50,000 on Hawaii Island. In 2006, Hawaii Department of Health finally banned new cesspool construction. It was the last state to do so in the nation, followed by Rhode Island in 1968. In 2007, the state legislature mandated that all cesspools be removed by 2050. Next slide. But symptoms of sewage pollution are becoming much more apparent on the outer main Hawaiian Islands in rural areas, such as Hawaii Island. And in these areas, coral reefs are still relatively healthy, underscoring the urgency for improved sewage disposal management. Hence, Hawaii's strategy's coral reef objective number 1 is to reduce key anthropogenic threats to near-shore reef sites. Pu'uko is located in one of the 2 priority sites for the state for site-based actions. Pu'uko's reefs are considered some of the richest in the state. But according to a recent Hawaii Division of Aquatic Resource report, Pu'uko's reefs are in dire straits. Coral cover has decreased 35%, with algal cover increasing 38% over the last 30 years. It is suspected that sewage pollution may be one of the contributing factors to these documented changes in Pu'uko's reefs. Next slide. Concerns over sewage pollution at Pu'uko are not new. Residents have been concerned since the 1960s. In the 1990s, Pu'uko was designated as a critical wastewater disposal area. These are areas where wastewater has or may cause adverse effects on human or environmental health due to existing hydrogeologic conditions. In Pu'uko, the condition is that the cesspools are in close proximity to the water table. As a result, homeowners building new homes or renovating existing ones are required to install septic tanks. Next slide. So in 2013, the Pu'uko Community Association enlisted UH Hilo and the Nature Conservancy to help answer one question: is sewage in Pu'uko's waters? And since then, we have been collecting information through several research projects to address this question. And the answer is yes. How do we know? Over the last several years, we have made measurements of sewage indicators as well as conducted dye tracer tests. And from this research, we have shown that sewage is present and traveling from homes to the shoreline within hours to days. Although we have documented this, many community members have asked us whether upslope communities or adjacent resorts, whether they could be contributing sewage pollution to Pu'uko's coastal waters. Our most recent effort has sought to address this question, as well as to answer whether the type of sewage disposal system that a property has, whether it matters with regard to nearshore water quality. Next slide. So to do this, we sampled groundwater from wells at Waikoloa Village, as well as at the Mauna Lani, and coastal waters from the resort shorelines at the Mauna Kea and now the Hapuna Weston, Fairmont Orchid, and the Mauna Lani. These waters were indicated for sewage indicators. And here's what we found. Next slide. We looked at Enterococcus. This is a fecal indicator bacteria. And along the Pu'uko shoreline, it had concentrations that often exceeded the Hawaii Department of Health single sample standard of 104. Upslope wells and resort shoreline waters had low concentrations that were well below this standard. The US EPA Marine Recreational Water Standard is 35. This is a geometric mean, and it's used to tell you your health risk when swimming in waters. So if you go in waters that have a concentration of 35, your chance of contracting gastroenteritis is about 4%. Most of the concentrations we see along the Pu'uko shoreline are 2 to 3 orders of magnitude higher than this EPA standard. And the last time I gave this talk, they had just closed one of the beaches at Pu'uko for exceeding the standard. The concentration was over 300. Next slide. Now, because Enterococcus can be naturally found in Hawaiian soils, the Hawaii Department of Health uses a secondary fecal indicator bacteria, Clostridium perfringens. This is thought to be a more indicative indicator of sewage pollution. Clostridium perfringens concentrations along the Pu'uko shoreline often exceeded the recommended marine recreational water standard of 5, with several stations having values indicative of non-point sewage pollution, which is between 10 and 100. All the concentrations of Clostridium perfringens in the upslope wells and at adjacent shoreline waters were low and often undetectable. Next slide. We also used a newer method, Bacteroides, where they've developed a molecular technique to identify Bacteroides from the human gut. This is the most abundant bacteria in our digestive tracts. And what we found was that the only place we got positive hits for human Bacteroides was along the Pu'uko shoreline. Neither in upslope wells or at adjacent shoreline resort waters did we find it. Also, it has been shown that when you have concentrations of human Bacteroides somewhere between 1.7 to 3.6 copies per 100 mil, your chance of contracting gastroenteritis is somewhere between 1 to 3%. The concentrations along the Pu'uko shoreline at some of the stations were within this range. Next slide. We also measured stable nitrogen and oxygen isotopes in nitrate. Nitrate is a nutrient that can cause seaweed and algae phytoplankton to grow. At Pu'uko, we found values that were indicative of sewage, +7 or higher, while values upslope and at adjacent resort coastal waters were indicative of soil and fertilizers. Next slide. We also wanted to determine how much of that nitrate along the shoreline was derived from sewage. To do this, we used our stable isotope nitrate measurements in a statistical mixing model. We found that sewage contributed 40% or more of the nitrate at 10 of the stations along the Pu'uko shoreline. Several of these stations have previously been identified as sewage pollution hotspots from either nitrogen 15 measurements in seaweed, a sewage pollution score that we developed in a prior project, or through the dye tracer test. Next slide. The second question our project wanted to address was whether does the type of sewage disposal system matter, particularly with regards to coastal water quality. Next slide. To do this, we did dye tracers. 8 tests were conducted, 4 at cesspools. Cesspools are unlined holes in the basalt where wastewater from the home is disposed. 2 septic tanks. These are plastic tanks where the wastewater goes in and diffuses out into a leach field. And then 2 aerobic treatment units. These are a little bit more sophisticated septic tanks that do some additional treatment of the wastewater before going into the leach field. And what we found from our dye tracer test is that the dye traveled from the homes to the shoreline in less than 5 hours and up to 10 days. And it didn't matter what type of system the home had. In fact, we found that both the shortest and the longest travel times came from the aerobic treatment units. Next slide. So how can this be? Well, the thing is that the underlying geology matters more. And dye traveled fast in areas where there are large cracks in the basalt and the water table is close to the ground surface. Where the cracks in the basalt are smaller or fewer and the water table is deeper, it takes a much longer time from the dye to travel from the home to the shoreline. Next slide. We also assessed water quality in front of the homes with different types of systems. We found that the water quality was similar in front of homes where we sampled, regardless of the system type that the home had. For example, Enterococcus was similar in front of homes with different types of systems, and the concentrations were greater than the Hawaii Department of Health standard. Also, we found the same pattern for nutrients. Looking at total dissolved nitrogen, we found that its concentration was similar in front of homes with different systems and exceeded 100 micromolar. Next slide. We also wanted to evaluate different scenarios that the Pu'uko community is considering with regards to wastewater treatment and collection. So we wanted to see, under present conditions, how many stations would exceed the Hawaii Department of Health standard for Enterococcus, and how that might change under two different scenarios. So under present conditions, we found that 81% of our stations exceed the Hawaii Department of Health standard with regards to Enterococcus. If Pu'uko was to transition to all septic and ATU units, only 69% of the stations would exceed the Hawaii Department of Health standard. The third scenario is that all cesspools, septic tanks, ATUs would be removed from Pu'uko, and that either a sewage treatment plant would be built within the community or a sewer line would be built connecting the community to the sewage treatment plant at the Manalani Resort. And what we found in the last scenario is that the concentrations would dramatically drop and would be consistently below the Hawaii Department of Health standard, because sewage would no longer be going directly into the coastal waters at Pu'uko. Next slide. So in conclusion, we found that sewage indicator values were greatest at Pu'uko. This was the primary location where sewage was entering into the water table and going into Pu'uko's nearshore waters. The sewage reached the shoreline quickly, within 5 hours to 10 days, and this was regardless of the system type. In fact, geology was much more important in determining the travel time from the home to the shoreline. And when we looked at the different scenarios that Pu'uko is considering, we found that converting to a sewage treatment plant would remove the pathogens from the coastal waters. And this is important because this will minimize impacts to both human and coral reef health. Next slide. Mahalo for your attention. I'm happy to take any questions.
Mahalo, Tracy. Thank you for getting us started today. And since we did start a little late, if you have any questions for Tracy, you can type them into the Q&A box and she will be able to type an answer to you. So we are going to move on to our next speaker now. Thank you, Tracy.
Thank you, mahalo.
All right, next up we have Danielle Bartz, who is a student of HCFRU and a student at UH Manoa.
Aloha, mai kako. Thanks, Carmelita. So yeah, my name is Danny, and today I'll be giving a very brief talk on my dissertation research, which is titled The History of Hammerheads in Hilo and the Interdisciplinary Approach that my advisor, Tim Grabowski, and I have decided to take. Next slide, please. So I'm sure as many of you already know, issues in conservation biology often lack adequate monitoring data. And in these data poor systems, it makes it very difficult for resource managers and scientists to make informed decisions. There's currently a lack of baseline population monitoring data for many imperiled species throughout the globe. And unfortunately, this can at times cause overlooked losses in biodiversity. And also at times there are little to no published baseline data in the scientific literature However, there is often a wealth of knowledge, observations, and experiences concerning whatever species of interest within the local community. Next slide, please. So bringing this a little closer to home, we all in Hawaii love sharks, right? So scalloped hammerhead sharks are endangered throughout the globe. However, they're not currently protected in Hawaii. Disclaimer, I don't think that protection laws per se are like a standalone answer to any issues facing, conservation biologists. However, it is necessary to understand and have a general sense of the population dynamics of any imperiled species prior to taking any form of action. So as many of you probably already know, sharks or mono are culturally and ecologically important here. Culturally, many species or individuals are amakua, so like a family, or a ahupua as god or protector, guardian, as well as their ecological role as apex predators, because they just help regulate the entire ecosystem function and keep things in check. So in 2017, anglers within the local fishing community of Hilo Bay approached the Division of Aquatic Resources with concerns of a perceived decline in scalloped hammerhead populations in Hilo Bay. Next slide, please. So we saw this as an auspicious model system opportunity to kind of meld different techniques and methodologies and kind of bring social science and a more traditional biological science together to understand what's going on here. So that leads me into my objectives. Next slide, please. The first objective of my research is to assess the use of traditional, ecological, and indigenous knowledge, which I'm calling for short TEK/IK, in developing baseline data estimates. Next, to assess the use of acoustic telemetry to monitor current species distributions, site fidelity, and residency patterns, and then to bring the two together and to coalesce the traditional, ecological, and indigenous knowledge with the acoustic monitoring data to quantify Hilo Bay as a shark nursery habitat. And lastly, to hindcast abundance estimates to determine potential population declines using modeling. So next slide, please. I'll get into how we're gonna do that. But first, briefly, I'd like to just introduce our study site. So Hilo Bay, located on the east side of Hawaii Island. Next slide, please. So this is a rough overview of the methodology. We'll begin by collecting traditional, ecological, and indigenous knowledge through interviews within the local community. So mostly fishermen, but really anyone that has an intimate relationship and years of experience in Hilo Bay. So it could be paddlers, surfers, divers, just people that know and love the bay. Next, we will monitor spatiotemporal patterns through the use of acoustic telemetry, so just your basic shark tagging and tracking. And lastly, we will generate species distribution models and habitat suitability models for baseline reconstruction. So essentially, we're trying to first reconstruct this baseline of the past and then use the acoustic telemetry to figure out the current population dynamics and then compare the two. Next slide, please. So just to kind of give you a visual of how this is going to work, the dark circles represent the roughly 250 meter detection range of our VEMCO acoustic receivers, which will be strategically moored throughout the bay. And then the dotted red rectangles broadly represent the interview sites for the collection of traditional, ecological, and indigenous knowledge, as well as our shore fishing locations. Next slide, please. All right, so you may be wondering how we plan to turn this nebulous form of he said, she said data into a database that is useful for scientists and resource managers and the community. So this is just a little graphic that I snipped from a paper from Scroblin et al. 2020, but I like it because it nicely shows how you have these ecological processes, and then you have your indigenous or ecological knowledge within the community, and then your detection data, which in this case will be like the presence only data generated from the interviews and the acoustic data, and then pairing that with some spatially explicit predictors and some environmental variables, then you can generate species distribution or habitat suitability models. Next slide, please. So just some broad anticipated outcomes for this research. First and foremost, to highlight the efficacy of coupling this local ecological knowledge with more traditional like Western science methodologies to produce useful data. And by useful, I just mean data in formats that are compatible with the needs of resource managers and the community and science, like taking it all and making it into something that we can actually deliver. And then next, to determine if scalloped hammerhead population in Hilo Bay is declining or if there have been any potential shifts in the use of nursery grounds. Then we will use models and ArcGIS story maps to kind of understand and portray past and current baseline estimates and make comparisons. And lastly, to hopefully guide future conservation efforts and think of the most like Pono way that we can go about this if there even is a problem, because first we just need to understand what's going on. Next slide, please. These are my references, and next slide, please. Mahalo nui loa. Thank you for your time. Aloha.
Thank you, Danielle. Again, just to keep on time, if you have any questions, you can type them into the Q&A box and Danielle will be able to type an answer to you. All right, next up, we have Jordan Hemmerly, who is part of the Marine Science undergraduate program at UH Hilo.
Hi, everybody. So today I'm going to talk a little bit about scleractinian corals at Papahanau'umukuakea. Most specifically, the majority of the sites are in the French Frigate Shoals. I think there might be one or two that are outside of it. But this was a really cool project, and it was funded both by Megalab and eGavi. We can go to the next slide. So the first thing that's going to happen, you guys can see there's like a little diver over here in the corner. When you go into these 3D survey methods, basically what's going to happen is you can either snorkel or scuba. You take a regular camera with you as long as it's good for underwater, you're good. From there, you're going to swim in like kind of a sort of Z shape. And all of these plots have like a 30-meter transect line. You can kind of tell it is the yellow line that goes across the image. Over here on the right, there's like a little thingy sticking up. That's just a buoy, but realistically, X can mark the spot however you feel like you want it to. And then you also are going to lay down just like a 1 meter by 1 meter regular square. It can be made of PVC pipe or tape, anything that's just going to actually stick. So that way you have a scale for when you go into the next kind of portion, which is where you're going to take all of these formerly two-dimensional images and put them through a software called Agisoft PhotoScan. This is giving us our structure from motion photogrammetry. It's going to calibrate and render not only a digital elevation model, but also an orthomosaic photo image, which is what we end up with in the background here. Once we have those like two-dimensional orthos, the very first one that we ran them through is over here on our bottom left. That is CoralNet. So that is a tool from University of California, San Diego, and we use the beta version. In CoralNet, you can put as many random points on an image as you so choose. We chose to do 1,000 random points across our 5 by 10 meter plots. So this gives us like a pretty solid indication of what's happening on the reef, because for each of those 1,000 points, we're then going to turn around and label them. CoralNet does have partially automated annotations. It does use machine learning. We annotated ours manually over summer. It was super fun. And then we have our, I'm so sorry. I got vaccinated yesterday and don't feel super great. But we had our grad students come back and quality control those. So then we also have in the middle is our full annotation plot. So that square, even though it looks really tiny now, is still the 5 by 10 meters. That's a plot that I annotated myself. You can't really tell, but each individual little color and little shape in there is its own coral that was labeled and outlined. Everything that's left in the background without any annotation over it is just turf. That method is amazing because it is like kind of like a control plot sort of, because you have a researcher going in and looking individually for every single coral that's there. That particular reef took between 40 to 60 hours to annotate. So it's a much, much slower process than the CoralNet, which has 1,000 points and you get to quickly go down the list and click the label that you so choose. On the very right side, it is a little bit difficult to see, but there are 20 blue circles scattered throughout that same orthomosaic image. This method with our little circles in it, what we're looking at is coral over time. So these are plots that you're probably going to want a couple years worth of photos that you can go back and look through. And these circles are placed over corals that appear over those years. So you can measure your vital rates, your growth. It's not typically used to compute total cover, which is part of why I wanted to see if it would work if we did it. So I was really excited. The other thing about that method is that for the vital rate circles, we are digitizing those in triplicate. So there are 3 copies of every document. Ultimately, at the end of the day, in terms of workforce power, having 3 people come into those vital rate circles is probably the same amount of time and money that it would be to have 1 person go in and annotate the full plot. We do those in triplicates just so that we can prevent observer bias. And when we are computing total cover, we actually clip anything that eclipses the circle. So if the coral is kind of half in, half out, it'll end up getting cut in half. And that's just to prevent like survey sample area bias. We can go to the next slide. So, okay, so we ran a few linear models here that were all really, really good, adjusted R2 values, and that is just the goodness of fit. So that's when you have like your scatter plot, you put a line through it, and you're trying to measure how good that line fits. With simple linear regressions, we were looking around the 83 to 88% goodness. But when we go into the multilinear regression down here, we have like a 90% fit, which is amazing. The plot on our top right is just a density plot. So you can see the majority of the reefs in this study really had between like 15 and 40% total cover. We did have some reefs that were quite full. So if you look on the bottom plot, at the top right-hand corner of the bottom plot, you can see that there is one line that is much taller. That is a control plot, and it was definitely our highest input. It had around 93% total cover. And so you can kind of see the difference between the other 2 methods where the measurement of that was largely skewed just because that was such a high input. Alternatively, on the other side of the graph, you can see where one circle had like dipped down a bit. That's our lowest ringing plot. It came in at 14%. So there has been a lot of interesting questions answered, and there's a lot more to answer with exactly how accurate each method is and what the cost of it would be and which is the best to use. With that said, CoralNet is definitely the fastest, and there's no competing with that. So those are the 3 methods I've been checking out, and I will be talking about them a little bit more at the Data Science Symposium next month. So that's all I have for you guys.
Thank you so much, Jordan. And if anyone has any questions, we have time for one. Otherwise, you can type them into the Q&A and she will get those answered for you. All right, I think we're just gonna move on to our next speaker. So thank you again, Jordan. Next up, we have Sebastian A.W. Wells, who is a TCBES graduate student at UH Hilo.
Mahalo for the introduction, Carmelita. Can you guys hear me?
All good.
Okay, I'll take that as a yes. So aloha nui kako. My name is Sebastian Wells, and today I'll be giving my presentation about my journey as a TCBES professional intern, where I work with the County of Hawaii Real Property Tax Division under the guidance of Lisa Mira, Rebecca Ostertag, and Lisa Canali. So I want to thank you all for taking the time to be here today and for giving me the opportunity to present my graduate school internship project, which is entitled Expanding the Capacity for the Preservation and Restoration of Native Forest Habitats on the Island of Hawaii. As a quick side note, I just want to say that when I was an undergraduate at UH Hilo, I attended many TCBES symposiums where I was always inspired by the work previous cohorts were doing, and found myself wondering what it'd be like to present at the TCBES Symposium as a graduate student. So what started as a dream that was born out of my simple imagination, I just wanted to say to those of you in the audience who may be like me that never in my life did I ever think that I would be here today. So I just want to encourage you to keep following your dreams, because you never know what can happen if you do, and if I can do it, then so can you. So with that being said, mahalo for allowing me to share my story with you today. I feel very honored and privileged to be here. And one last thing before we begin, I just wanted to let you know that unless there's a photo credit associated with the pictures in my slides, then the pictures are those that I've taken during my time as a TCBES graduate student. So native forests are home to an extensive range of native and endemic species that support and sustain life here in the middle of the Pacific. Native wildlife and the associated habitat found throughout the Hawaiian Islands provides both, next. Yeah, so I'll start over. Native forests are home to an extensive range of native and endemic species that support and sustain life here in the middle of the Pacific. Native wildlife and the associated habitat found throughout the Hawaiian Islands provides both residents and visitors with a wide variety of ecosystem services, which really highlights the importance of native forests when it comes to maintaining human health and well-being, as native forests provide our county with fresh water, protect our world-class beaches from runoff, and are a critical link for the continuation of Hawaiian cultural practices. Next. So the modification of native ecosystems to pasture, agricultural lands, and other production-based land use types have been and continue to be one of the most significant threats faced by native forests in Hawaii today. As a result of Hawaii's geologic origin and geographic isolation, the endemic species that have evolved here lack the natural defense mechanisms required to successfully overcome the ecological challenges of competition, predation, and disease, and are highly vulnerable to the negative impacts associated with these disturbances. So to address the growing number of ecologic and anthropogenic issues that threatens the continuations of native forests, new conservation initiatives are being implemented to maintain native forest habitats, while also increasing landscape connectivity in areas that have been fragmented by human modification. Next. So one such initiative is the County of Hawaii Native Forest Dedication Program. Together, Dr. Rebecca Ostertag, who is the Associate Program Chair of the TCBES program at UH Hilo, environmental lawyer Leslie Cole Brooks, the Division Head Administrator Lisa Mira, and Kita Joe, who is the Assistant Administrator of the County of Hawaii Real Property Tax Division, Dr. Susan Cordell, who is the Director of the Institute of Pacific Islands Forestry, and myself have worked together over the past 2 years to develop a public policy initiative that was specifically designed for preserving and restoring native forest habitats here on Hawaii Island. So during the first year of this project, we worked on and advocated for Native Forest Bill 178 by quantifying the economic value of native forests and presenting written and verbal testimony to Hawaii County Council during the public hearing process. Now, once Native Forest Bill 178 was passed and signed into law in the fall of 2020, the second year of the project was based on developing materials to support the implementation of this new legislation. Next. So Native Forest Bill 178, which went into effect of January 1st of this year, expanded the Native Forest Dedication Program to include 2 types of dedications. The first is a preservation-based dedication, which is designed to maintain current conditions, which specifically pertains to forests that already have native forests with 60% native species cover, and a restoration dedication, which is dedication based on improving current conditions to develop a native-dominated forest in the future. Also new in the Native Forest Bill 178 is the addition of 2 new categories, which include a functional forest and a successional forest dedication. So the basic eligibility requirements for each native forest dedication type is that the land parcel be 3 acres or larger, with at least 2.75 acres being intact and contiguous native forest. So the first dedication type is a native forest dedication, which Leslie likes to refer to as the gold standard of the program. Under this land use designation, private landowners can dedicate their land to native forest preservation or restoration for a 20-year time period, with native forest being defined as an area of land which has 60% or greater native species coverage in the canopy, understory, or a combination of the two, with the land being assessed at a $7 per acre value. The functional forest dedication also has a preservation and restoration option, which also requires landowners to dedicate their land for a 20-year dedication period. So for the purpose of this land use category, functional forests are those that have 60% or greater native and non-native non-invasive species cover in the canopy, understory, or a combination of the two, with the dedicated land being assessed at a $14 per acre value. In this case, non-native, non-invasive species are those that have either a low risk designation or a Hawaii Pacific weed risk assessment score of 0 or less, meaning that they are unlikely to be or become invasive here in Hawaii. And the last category is a successional forest dedication, which pertains to lands that have new lava substrates in which the soil depth or organic material are less than 10 centimeters and is maintained to promote native or functional forest development over the 50-year dedication period and is assessed at a $100 flat rate. Next. So here are a few examples of the potential savings in property taxes when choosing to dedicate land to the Native Forest Dedication Program. It is important to note that tax savings will vary as the amount of potential savings is dependent on the market value and the size of the dedicated property. So for the first example, it's a property located in South Kona that is 6 acres in size. The respective taxes to be paid annually based on the native forest value of $42 would be $200, which is the minimum tax in Hawaii County. So based on the market value and the size of the property used in this example, the annual savings by dedicating land to native forest dedication for this property would be $1,754. The second example is a property located in Hamakua that is 602 acres in size. The respective taxes to be paid annually would also be $200, which again is the minimum tax in Hawaii County. So the annual savings for the property in this example would be $32,571. And the last example on this slide is a property located in South Kohala that is 22 acres in size. So as I mentioned earlier, successional forests are assessed at a flat rate of $100 regardless of the size of the property. So the respective taxes to be paid annually based on the successional forest land use dedication in this example would also be the minimum tax of $200, with the annual savings being $13,722. Next. So in an effort to take the guesswork out of helping landowners determine what plants they can use to meet the requirements for the different native forest designations, I developed a native, non-native, non-invasive plant species list that helps individuals determine what types of plants they can incorporate into their native forest restoration endeavors. The native, non-native, non-invasive plant species list includes 68 native and 66 carefully selected non-native, non-invasive plant species with descriptions of each plant, their preferred growing conditions, and how to successfully cultivate each species. This list allows landowners to correctly identify, select, and cultivate different plant species based on elevation gradients, moisture regimes, and their preferred growing conditions. After this list was compiled, I created another section which included a photograph and description of each plant species and helpful tips on how to ensure plant growth and plant viability. Next. I also created an accompanying document with a directory of where some of the plants featured in the native plant species list can be purchased. The native plant nursery list includes an alphabetical list of Big Island nurseries that specialize in selling and distributing native plants, as well as each nursery's contact information, which includes the address of the business, their phone number, and their email address if it was available. Next. Another document that was created to support the Native Forest Dedication Program is the Native Forest Dedication Program Management Plan and Guidelines document, which is intended to provide landowners with a resource that they can use to help them navigate the process of qualifying for one of the Native Forest dedications mentioned earlier. So this document includes a simple step-by-step guide on how to dedicate land to one of the 3 Native Forest dedications and a management plan template that takes the guesswork out of developing Native Forest management plans. So in an effort to simplify the process of helping landowners select the Native Forest dedication type that most closely corresponds to their current situation, I created this table, which was designed to help landowners decide which land use dedication is best for them. So each dedication type is listed above and has a corresponding color that highlights the eligibility requirements for each land use type, the type of zonation, and how each category differs in terms of native forest structure. Next. So as I mentioned earlier, the management plan and guidelines document was designed to give landowners a simple step-by-step guide on how to dedicate land to native forest. Now, with the guidance and support of Tanya Rubenstein from the State of Hawaii Forest Stewardship Program and Matthew Cocking of NRCS, I was able to develop a document that allows landowners to write an ecologically sound native forest management plan without the help of a natural resource professional, while also helping them meet the eligibility requirements listed in the Hawaii County Code. Next. And lastly, to help raise awareness and provide the general public with information related to the Native Forest Bill 178, I helped develop, design, and co-host a webinar, which was intended to unpack the newly updated Native Forest Dedication Program. So the Native Forest Preservation and Restoration Tax Incentives for Hawaii County Landowners webinar was hosted on February 11th of this year, with 48 individuals from the general public being in attendance. This webinar was recorded and later converted into a YouTube video, which is now available for the general public to view at their convenience. Next. So as of right now, there are 155 parcels participating in the Native Forest Dedication Program, which represents 70,263 acres of land being dedicated to native forest preservation or restoration. Now, while the number of new applicants has been relatively low since Bill 178 went into effect this year, the staff at the Real Property Tax Division has reported that there has been increased interest in this program as they have been receiving more calls about this land use designation. So my hope is, as the number of applicants increases, that the documents that I created will help the Native Forest Dedication Program bloom, as the County of Hawaii Real Property Tax Division and the general public will have the resources they need to successfully implement this newly updated program. Next. So in conclusion, the expansion of the County of Hawaii Native Forest Dedication Program illustrates the efficacy of increased collaboration between government agencies, researchers, legal fellows, and private landowners to effectively preserve and restore native forest habitats here on Hawaii Island. As native forest habitats are primarily managed by various state, federal, and nonprofit organizations, the County of Hawaii Native Forest Dedication Program promotes community engagement in the active care and management of native forest habitats, allowing for the cultivation of healthy forests and healthy communities right here on the Big Island of Hawaii. Next. So before I finish, I would just like to send a very sincere and heartfelt mahalo to Rebecca Ostertag for the unwavering support you've provided me throughout my graduate school journey, to Lisa Canali for all the knowledge you've instilled in me as a TCBS professional intern. I would like to thank the Hau'oli Maoloa Foundation for your very gracious and generous funding. I would also like to thank the Native Forest Dedication Program Working Group, Leslie Cole Brooks, Susan Cordell, Lisa Mira, and Kita Joel for all the knowledge you have shared with me while working on this project and for everything you do to preserve and protect our native forest habitats. I would also like to thank the PIPES program and program leaders, Sharon Ziegler-Chong, Clinea Hugh, Rita Miller, and Jordan De Jesus, for showing me the path towards a career in conservation and helping me grow into the individual I am today. And lastly, I would like to thank my family, my friends, and my cohort for always being there for me during this journey through graduate school. There's no way I could have done it without you guys, so mahalo. And next. And here's a list of some of the additional resources that I had mentioned throughout my presentation, in addition to a link to the County of Hawaii Real Property Tax Division website and a link to the Native Forest Dedication Program webinar. So if there are any questions that aren't answered during the Q&A section of this presentation, I've included my email, so please feel free to just reach out, and I'll be happy to do what I can to get those questions answered. And with that, I'd like to thank you for taking the time to be here, and I'll happily take any questions that you may have. Mahalo.
Thank you, Sebastian. We do have a question already. So, are there any plans to expand this program to other islands?
Okay, so to answer your question, Patrick, yes, there are. Currently, the environmental lawyer, Leslie Cole-Brooks, is looking at expanding this program and taking it to some of the other counties throughout the state. Because the land use types here on the Big Island are quite unique, especially in terms of successional forests. She doesn't think that the same legislation will be carried over into the other counties, but she is exploring the option of taking it over to different islands throughout the state. So to answer your question, yes.
All right, and I think we have time for one more question. And this is, if you are a landowner and your land has already been heavily impacted by invasive species, would you need to remove them in order to qualify for this bill? Or would you survey for a base level and need to keep this baseline level or above?
So to answer that question, that's where the beauty of the functional forest restoration project comes in. You know, one of the things that Dr. Rebecca Ostertag and Susan Cordell recognize is the challenges of restoring a forest or a native forest to its original condition. So the functional forest dedication allows landowners that have properties that are severely degraded by invasive species and other conservation-based challenges to work towards restoring a native forest, but also being eligible for the tax incentives offered by the county.
Thank you so much, Sebastian. That was a great talk.
Well, thank you.
All right, next up, we have Kainalu Stewart, who is a TCBES graduate student at UH Hilo.
Mahalo for that introduction. Yeah, okay, I'll hail Oko and Ipukukui Pio Ole Kana Awao. My name is Kainalu Stewart, and today I'll be talking about my internship project entitled Collaborative Efforts to Re-Evaluating the Vulnerability of Lalo in Papahana Mokuakea. Next slide, please. Papahana Mokuakea Marine National Monument, also known as the Northwestern Hawaiian Islands, is the largest fully connected protected area under the US and is one of the largest marine conservation areas in the world. Next slide, please. Papahana Mokuakea is also a prime center of biodiversity with many unique species only found in the Hawaiian island chain, from diverse corals, fish, marine mammals, birds, and other flora and fauna. Next slide, please. This place also embodies great cultural and spiritual significance to the Hawaiian people, with many heiau or religious shrines that still stand and exist today, particularly on the islands of Nihoa and Mokumanamana. Next slide, please. These Kupuna Islands represent Papahana Moku, commonly known as Earth Mother, and Wakea, commonly referred to as Expansive Sky Father. This union resulted in the birthing of the Hawaiian archipelago, which is directly connected to the Hawaiian people. Next slide, please. Kealanui Polohiwa Kane, or the Tropic of Cancer, separates the islands into two realms called Po and Ao. Po means darkness and is believed to be the place where spirits and the gods return after death, and Ao is the realm of the living. Next slide, please. For my project, we'll be focusing on the largest atoll island, known as Lalo, or French frigate shoals, and Lalo translates to down, lower, under, or beneath, which also describes the atoll island's characteristics. Next slide, please. So Lalo is an open atoll consisting of a large crescent-shaped reef expanding over 744 square kilometers, surrounding numerous small sandy islets. These reefs support over 600 species of invertebrates, along with numerous other species. Next slide, please. Atoll islands form when corals build a colony around the top of a volcanic island. As time passes, the reef reaches the surface of the water and becomes land. A lagoon then usually forms as the volcanic island shrinks. Next slide, please. The existence of atolls are heavily dependent on coral reefs, as that is the foundation to it forming. And so as corals erode to sand over time, they then pile up to form what we know as an atoll. Next slide, please. Because atoll islands are low-lying, they are even more vulnerable and susceptible to impacts from climate change, especially sea level rise, and more frequent hurricanes that contribute to coastal erosion. Next slide, please. In addition, Lalo is where over 90% of the green sea turtle population go to nest and breed. It is also a common refuge for the endangered Hawaiian monk seals and many migratory seabirds such as the Laysan albatross. Next slide, please. With these heightened impacts of sea level rise and climate change, more managers are becoming concerned for the future of these vulnerable habitats that many flora and fauna rely on, such as the honu and the monk seals. Next slide, please. In addition to coastal erosion, atoll island communities across the globe face impacts of inundation and flooding from sea level rise that directly affects its thin water table, which species such as plants also rely on. Next slide, please. So this image is a picture of the recent 2018 Hurricane Walaka that nearly wiped out East Island at Lalo, which is a critical nesting habitat for sea turtles. It gives us a glimpse to how vulnerable these habitats are and what we may expect with increased climate change. Next slide, please. So as scientists and managers alike become more concerned for Lalo and its future existence, we remain steadfast in the idea of working together to adapt best practices in current and future management. Next slide, please. So with my mentor guiding me, we look towards the horizon and begin to pull in multiple managers and experts from different backgrounds to develop a collaborative survey and identify their main concerns and potential opportunities for future management. Next slide, please. Additionally, I will be mapping shoreline change of these sandy islands to monitor the shifts in recent years. The goal is to assess places most at risk and identify resilient areas and how that will affect management decisions, such as relocating species to more stable habitats. Next slide, please. Overall, this project will contribute to a greater strategy document for the monument to develop best management practices and better understand impacts of sea level rise and climate change, as well as encourage collaboration. Next slide, please. Like our kupuna that endured and traversed the unpredicted seas of Kanaloa, we are products of resiliency, just as these kupuna atoll islands are, despite the unpredicted impacts that they face. Next slide, please. And so with that, I just want to extend my mahalo to my mentor, Dr. Haunani Kane, also Dr. John Burns and the Mega Lab, my TCBES Kumu and cohort, and mahalo nui to everyone for listening and engaging in my talk. And if there's any questions, I'll be happy to answer.
Mahalo Kainalu. We have about 1 minute for questions. You can ask them in the Q&A box. All right, we have a question from Pat Hart. Kainalu, how do you plan to map the changes over time on Lalo?
Great question. Mahalo, Pat, for the question. So we plan on looking at satellite imagery using Planet Labs, and then also hopefully being able to take drone images when we have the opportunity to go back up to Lalo. But yeah, we'll be just tracing the shorelines each month to see the shifts of the impacts, I guess, to the coastal erosion, and try to identify how that will be also affected with future sea level rise.
Awesome. Thank you, Kainalu. All right, we're going to move on to our next speaker. Here we have Carmelita Villalobos, a TCBS graduate student here at UH Hilo.
Thank you, Lisa. All right. Aloha, and thank you everyone for joining me for my talk about Hawaiian monk seals and their population on Hawaii Island. Since last September, I have been working with the Marine Mammal Center to monitor and protect the Hawaiian monk seal population on the island of Hawaii while educating others on their importance. Next. I will begin my talk by giving a background on Hawaiian monk seals and the threats that they are currently facing. I will follow this with an introduction to the Marine Mammal Center and Keikaiola. I will discuss my role at Keikaiola, the objectives of my internship, the approach I took to accomplish my goals, and the deliverables I was able to create. Next. Hawaiian monk seals are one of only 2 monk seal species. They're the most endangered seals worldwide and are the most endangered pinniped found in US waters. Although endemic to the Hawaiian archipelago, known to be found 3.5 to 11.6 million years ago, many people have the misconception that they were introduced and are considered a nuisance by fishers and beachgoers alike. Hawaiian monk seals were around before the arrival of the Polynesians, who landed in Hawaii in 1000 to 1290 AD. Sadly, seal expeditions in the 19th century drove the population to near extinction. Hawaiian monk seals were extirpated early, so people did not grow up with them, and when NOAA tried to reintroduce them, people looked at them as invasives. Misconceptions and poor outreach led many to hate them, even going as far as killing them without reason. The result is that today, there are only 1,400 monk seals left in the entire Hawaiian archipelago, 300 being found in the main Hawaiian Islands and only 10 being found on Hawaii Island. Next. Hawaiian monk seals are named as such because of the way the skin on their necks folds like a monk's hood. They are born black, but get dark gray to brown on their dorsal side and light gray to yellowish brown on their ventral sides as adults. This is a mom next to her pup, which really shows the contrast in color and in size. Full-grown adults weigh between 400 and 600 pounds and live to be between 25 to 30 years old. Next. Hawaiian monk seals spend their time between the terrestrial and marine environments, with 2/3 of that time being spent at sea. In the ocean, seals can be found foraging or traveling and rest, molt, and pup while on land. This number kind of shocked me because as a volunteer, we spend so much time looking for these seals on land, and it seems that they're always out of the water. I have only ever encountered a seal one time while swimming, as opposed to the hundreds of times that I have seen them resting on the beach. Next. So when I encounter a monk seal, this is usually what they look like. Monk seals are solitary and are almost always found alone. Even though there are only 10 seals on Big Island, a very large volunteer force is needed to monitor them since they are rarely found in groups. For example, we may have 6 seals hauled out in one day, all on different beaches at the same time, therefore needing 6 individual volunteers to assist. While responding to a seal resting on a beach, people often ask me how long they will rest, but it really depends on the day and on the seal. Just like you and I, they have their own agendas. Monk seals can stay on beaches anywhere from a few minutes to an entire day. Next. Every year, monk seals undergo a catastrophic molt where they shed their top layer of fur and skin. This takes about 1 to 2 weeks, depending on the seal's age, weight, gender, and the female's reproductive status. This is done on land, and seals won't return to the water until they are completely finished. This means that they may go a week or 2 without foraging. Next. Female Monk seals can start reproducing as early as age 5 and usually will reproduce until around the age of 10. Gestation takes around 10 to 11 months, and during this time, mothers put on extra weight to be able to support their pups during weaning. Pups are born at around 25 to 30 pounds and are weaned between 110 and 175 pounds. If you thought that seals may get hungry while they're molting, it is nothing compared to what a mother does for their pup. Mothers do not return to the sea to eat while their pup is weaning and lose weight while the pup gains weight. After 5 to 7 weeks, the pups are weaned and mothers return to the ocean. And at this point in time, the mother and pup are very similar in size. Next. Monk seals are generalist feeders, meaning that they eat anything from fish to squid, octopuses, eels, and crustaceans. They mostly forage at or near the sea floor, which is when their diving time really comes in handy. So they can hold their breaths anywhere from up to 20 minutes and can dive as deep as 1,800 feet. Generally, though, they take dives around 6 minutes to about 200 feet. Although it is thought by some that monk seals create competition for fishers, they actually don't target locally popular game fish. Next. Monk seals also travel in the water. So I know it's hard to see here, but there is a monk seal in this picture. They don't complete a seasonal migration, but can be known to travel hundreds of miles up and down the Hawaiian archipelago. It is not uncommon for seals to hang out around one island all year, but then travel to another island just to pup. For example, we have a seal who hangs out around Hawaii Island for most of the year, but then travels to Kauai to pup. Once her pup is weaned, she will most likely return again to spend most of the year with us. Next. There are many threats to Hawaiian monk seal population, and unsurprisingly, the threats vary by area along the archipelago. So in the northwestern Hawaiian Islands, entanglement is by far the largest threat. Derelict fishing gear is commonly found in those waters, and monk seals, being the curious creatures they are, often find themselves entangled in gear, or as you can see, with gear in their mouths. Food limitations due to overfishing are also a threat, in addition to shark predation on pups, which is an uncommon behavior but has been seen more frequently. In the main Hawaiian Islands, fisheries interactions, human interaction, and infectious disease are the top threats to monk seals. Next. Hawaiian monk seals have the highest entanglement rate of any other pinnipeds. In the northwestern Hawaiian Islands alone, 800 metric tons of debris have been removed since 1996. Although this is less common on the main Hawaiian Islands, we still see this occurring along with increased hookings. If you were around for Mike's talk yesterday, you know that marine debris is a huge problem that we are trying to combat. So it makes sense that seals may be affected by this. We also see negative seal and fisher interactions, since some believe that seals are eating all of the valuable fish. Next. This leads to the next threat of human interaction. There have been many instances where people will go as far as killing seals to prevent them from eating fish, although they are protected by the Endangered Species Act. More common a threat, though, is disturbance. So I love this picture because it may seem like a harmless picture of a resting monk seal, but there are many things wrong with it. So this picture was taken from way too close of a distance. And you can tell because you can see that the animal is looking right at the camera. It's very aware that someone is near it. The simple act of grabbing the seal's attention is disrupting its normal behavior. I actually responded to the seal and almost stepped on her because the person taking me to her did not understand how far away we should be, and I didn't see her because she was blending in so well with the rocks. Next. The last big threat on the main Hawaiian Islands is infectious disease. So if you live on Hawaii Island, you may be aware of the large feral cat population. So cats spread toxoplasmosis, which can be deadly to Hawaiian monk seals, as there is currently no treatment or cure. Monk seals may not directly interact with cats, but they can be exposed to the same beach areas, making them vulnerable to the disease. Next. It is clear that the Hawaiian monk seals face numerous stressors, which have threatened their population numbers since the 1900s. Luckily, the Marine Mammal Center, or TMMC, has been working to combat these stressors since it opened its doors in 1975. To date, the Marine Mammal Center has rescued more than 24,000 marine mammals throughout the California coastline and the Hawaiian Island chain. TMMC has been a trailblazer when it comes to ocean conservation because it has been focusing on marine mammal rescue, research, outreach, and veterinary medicine for decades. The ocean is in need of our help because it is suffering from a multitude of anthropogenic threats, including marine debris, overfishing, and rising ocean temperatures, each of which have threatened the livelihood of the organisms that call the ocean home, including Hawaiian monk seals. The main mission of the Marine Mammal Center is to advance global ocean conservation through rescue and rehabilitation, scientific research, and education to combat the negative effects of the changing ocean on marine life. All of this work is possible because of the more than 1,300 volunteers in California, Hawaii, and other islands that donate their time to responding to the animals and conducting public outreach efforts. Next. In July of 2014, the Marine Mammal Center opened a state-of-the-art hospital and visitor center on Hawaii Island named Keikaiola, or the Healing Sea. This facility was built to help save the Hawaiian monk seal population and is the only facility in the world of its kind. Of the approximately 1,400 monk seals alive today, it is estimated that nearly 30% are alive directly because of the conservation efforts by NOAA and the Marine Mammal Center. Seals all along the Hawaiian archipelago that need care are sent to Keikaiola for rehabilitation, since it is the only facility built specifically with Hawaiian monk seals in mind. Next. My responsibilities at the Marine Mammal Center fall under two main roles of response intern and volunteer manager. I am working directly under Lauren Van Hukelem. She's the response and operations coordinator at Keikaiola. And I'm doing this to gain hands-on experience working in response and outreach. So my responsibilities at the Marine Mammal Center include response and outreach, dispatch, identification, and volunteer training. Next. As a response intern, I am on the response schedule for 1 to 2 4-hour shifts per week. And in this role, I monitor the beaches on Hawaii Island and respond to seals that may be hauled out on high traffic beaches to conduct outreach to patrons that may be curious about the animals. And monitoring beaches may sound fun, and while it is most of the time, it is also difficult. So monk seals are deceivingly good at blending in with lava rock, and I often mistake them as such. If I'm able to locate a seal or get a call, I start by conducting a visual check of their bodies to make sure that they look healthy. Next. So this means looking at seals for new bite marks, unusual behaviors, any indicator that the seal might be in poor health or in distress. I then identify the seal by looking for tags or markers such as bleach marks and scars that are unique to the individual. Depending on whether the seal hauls out in an area close to human activity, I may have to set up a seal awareness zone, which designates a 50-foot perimeter around the seal. Next. This leads me to outreach. And what good is science if we do not share our knowledge with others? This is a huge part of working for Keikaiola because we want to spread the message of the importance of Hawaiian monk seals. Our main goal is to inspire others in hopes that they will help us care for the animals when we are not around and keep the health of our oceans in check. To do this, I will post up outside of the seal awareness zone and answer any questions citizens may have about the seal or monk seals in general. By doing this, I ensure that beach patrons keep their distance so as to not disturb the seals, and I also get to educate them on monk seals. My main hope is that they share this information with others so that our message is spread across the island. Next. After becoming familiar with the seals, I was able to create a field guide that would help volunteers easily recognize the individuals that are found on our island. So this meant sifting through hundreds of photos in the Keikaiola archive to find around 5 pictures per seal that would best describe them. I pointed out every single scar, bite, bleach mark, and tag number that was found on each seal to ensure easy identification for volunteers. This is important because identification is how we keep track of our seals, as we do not use tracking devices. Next. The Marine Mammal Center manages a response phone from sunrise until sunset every day. People can call this number to report Hawaiian monk seal sightings. Every Saturday, I have the response phone, which means that I field calls and dispatch volunteers to seals that may need response. So if you don't have this number already saved in your phone, you absolutely should, and give me a call if you ever come across a Hawaiian monk seal. Next. Lastly, I assist Keikaiola with volunteer training, which simply means that I have new volunteers shadow me in the field to show them how to identify seals, set up SAZs, and conduct outreach. The purpose of my internship with the Marine Mammal Center is to assist in monitoring the Hawaiian monk seal population on Hawaii Island and to engage with the community to educate them on monk seal conservation. My main hope is to inspire people to care not only about monk seals, but about the many organisms that make Hawaii unique and keep its ecosystems healthy and thriving. Next. And with that, I would like to mahalo my mentor, Lauren, the 2019 TCBES cohort, the many volunteers that I work with, and my advisor, Lisa Canale. I will now take any questions.
Mahalo, Carmelita. Your first question is posed by George. Do you have any current information on a seal or seals inflicting mortality on juvenile green turtles? And do you have any ideas as to why this would be happening?
Yeah, I'm glad you asked. That's been a talking point for us recently. So the best thing I can say to that is that monk seals are extremely curious creatures. And while this behavior has not been displayed by any of our seals before, it is not something that is extremely unusual. But we are we're very aware of the problem and we're monitoring the situation as best we can. But when it comes down to it, they are wild animals and there's nothing exactly that we can do currently to prevent this from happening. But we are trying to spread awareness that this is obviously not a great behavior, but a behavior that is common to curious creatures.
Thanks, Carmelita. Any more questions regarding this presentation? Go ahead and type them in the Q&A and we will ask them for you. All right, our next question is from Pat Hart. How big a problem are dogs to monk seals?
Another great question. We do have issues with dogs, I would say almost daily. So a lot of these beaches that we find the seals on should not have dogs on them to begin with, but people love to bring their dogs with them to enjoy the beaches. As long as they're on leash, we generally don't do anything about it, but we do make people aware that there are monk seals on the beach. And oftentimes people will respond with, oh, my dog is so well behaved. There's nothing to worry about. Like, just like the seals, they're just as curious. So they love to check out the monk seals. So we're super proactive about this. So usually it's not a problem. It's just getting owners to recognize that their animals are wild and there might be interaction between them. So to keep them on a close leash.
Awesome. Thank you, Carmelita. We're going to move on to our next presenter. We have Lily Gavigan, who is an undergraduate student at Hilo.
Mahalo, aloha mai kako, mai ka la pukai hae hae, ai ka moku lehua, aloha nui a kako. Like Isa said, my name is Lily Gavigan. I'm a junior at the University of Hawaii at Hilo, majoring in marine science, and I am so honored to be here with you folks today presenting about my current project analyzing and mapping culture significant sites on the island of Ko'olawe. Next slide, please. So to give a little bit of a background, the island of Ko'olawe is situated off the south coast of the island of Maui, and it is also known as Kanaloa. And settlers have been here or have settled this island since the year 400 AD. And this island was normally used for farming, such as walla plants or sweet potato plants. And it was also used as a navigation school where navigators would come and learn about navigation. And this island was also predominantly used for a lot of culturally significant events, such as ceremonies, such as rain ceremonies and others. Next slide, please. So on this island, the Ko'olawe Island Reserve Commission, who I've been working in conjunction with, has recorded over 83 culturally significant sites. And at these sites, there were a lot of organic matter that was found, including adzes that are mostly made of basalt, platforms, as you can see on the right, that is mostly made out of cobble basalt. And they have also been finding fragments of invertebrates, such as brain coral and other invertebrates, such as mollusks. Next slide, please. So the objective of this study is to quantitatively assess what these ceremonial sites mostly consist of in general. Since this is a pilot study, we just wanted to see what was out there. And this could potentially lead into insight into what past ecosystems or what the past ecosystem on the island of Ko'olawe looked like. Next slide, please. So the method of doing this pilot study was doing a qualitative analysis on the content that we found in these 83 sites. And these 83 sites were compiled into an Excel file by the Ko'olawe Island Reserve Commission. And we uploaded it to a program called Python, in which we conducted text analytics. And to conduct text analytics, we had to filter out these stop words and also do some topic modeling in order to assess the generalizations of what kind of objects were found on that island. And we also wanted to spatially map out the sites we did this using Google Earth Pro. Next slide, please. So far, this is what the map looks like of the 83 sites that were mapped by using grid mapping units. And so as you can see, most of the ceremonial or the culturally significant sites that they have recorded are found on the more northern side of the island. And on the other side of the island is mostly cliffs. So it's understandable why a significant amount of these sites were found on the other side of the island. Next slide, please. And so this is the word cloud that we were able to create using Python and text analytics that kind of outlines what we mostly found and what are the most consistently observed and recorded objects on the file of the recorded 83 sites. Next slide, please. And so this is an example of how we conducted topic modeling. So topic modeling, we tried to divide it up into a specific number of topics, and each topics had an assigned perplexity value. And the higher the perplexity value, the more precise or accurate that topic will be and effective that topic will be in generalizing the types of objects that are there on the island. Next slide, please. And so this is an output example. As you can see, for the analyzer, they have to come up with the topic name itself. So this is an example of how the whole document was divided up into two main topics. But at this point, it is very subjective, and it is up to the analyzer to identify what those topics are. Next slide, please. So for the future work, we hope to look at these materials within each ili or section of the land and to figure out if there are significantly different kinds of materials around the island compared to other sections of the island. Next slide, please. And I would like to extend a big mahalo to the EPP MSI NOAA undergraduate program for funding this, as well as the Ko'olawe Island Reserve Commission, especially Dean Tokishi and Carmela Nonenza for helping me out this project, as well as the Mega Lab, Dr. John Burns, Dr. Suko Hong, and Don McSwain for helping me out with the text analytics and mapping. Next slide, please. And I would like to dedicate this presentation and this project to Chad Kalepa Babayan, one of the most amazing pole navigators and kumu that I've had in my life. And I would like to extend a huge mahalo anui to him as well. Next slide, please. And I would like to extend a mahalo anui to you guys for listening to my presentation. And I would like to take any questions at this time.
Thank you so much, Lily. We'll see if we have any questions. I'll just say that I think the work that you guys have been doing is really awesome. I've seen a lot of it firsthand from Dawn. So I think it's really important and really awesome.
Thank you so much.
Okay, well, we have a question. Yes, okay. Are there any known cultural sites that you hope to explore and maybe map out since the bombing?
We do have a lot of culturally significant sites that are being monitored by the Ko'olani Reserve Commission themselves. Unfortunately, with this project, we weren't able to identify each and every culturally significant sites. They were just identified by their location. And so hopefully in the future, we can definitely, our goal is to create a user-friendly database to educate the public on these culturally significant sites. And that is definitely a huge goal that we want to individualize and to highlight some of these culturally significant sites that we can use to educate the public about the island itself. So thank you, Malia.
Thank you so much for your answers and for your great presentation. All right, so to take us into lunch, we are going to end with Sarah Jean Norbaum, who is a TCBES graduate student at Hilo.
Aloha, as Carmelita said, my name is Sarah Jean Norbaum, and I'm one of the TCBES graduate students. And I'd first like to give a big mahalo to the TCBES Maters Club for organizing this symposium, and a mahalo to all of you for coming to my presentation titled, Looking at the Whole Picture for Estuary Restoration. Next slide. First, I want to give a brief description of what estuaries are, explain why they matter, what is happening to these systems, and how to move forward with conservation, restoration, and management of these ecosystems, and how my mentor organization is trying to address those issues. Next slide. Estuaries are partially enclosed areas that often appear as a transition from land to sea. They are influenced by the tides and are places where fresh water from streams or rivers would mix with salt water to make brackish water. Just as a side note, there are freshwater estuaries that are chemically distinct from other bodies of water. Estuaries go by many names and have been called a bay, a slough, a lagoon, or a sound. They also consist of many different habitat types. Next slide. Estuaries are an important biome that provides valuable economic and ecological goods and services, such as acting as a water filter to minimize excessive nutrients, sediments, and pollutants from entering the ocean. They work to protect coastal communities by preventing erosion, stabilizing shorelines, and protecting these areas from harmful effects caused by extreme weather events such as flooding or hurricanes. They support diverse communities of plants and animals, which makes them a vital habitat for many types of wildlife such as fish, birds, amphibians, and terrestrial and marine mammals. They are often referred to as nurseries of the sea due to many species using estuaries to reproduce and using them for protection during vulnerable life cycles. They provide raw materials for building, medicine, and for food. Estuaries provide a habitat for about 75% of the United States commercial fish catch and contribute billions annually in trade and commerce for the United States economy. Next slide. Despite estuaries contributing so much and playing a critical role in human development, estuaries and other coastal ecosystems have been declining at a significantly accelerated rate during the last 150 to 300 years. This is due to multiple confounding impacts such as a loss of species, pollution, increased nutrients, degraded water quality, increased invasive species, and overall loss of area due to human activity. Estuarine health is an issue that should concern everyone in some way, especially those who live in coastal zones and depend on the protection of resources that estuaries provide. Despite restoration efforts, estuaries continue to decline. This is due to focusing on one aspect of estuary restoration rather than looking at it as a whole. This often means using an ecosystem-based management approach to try to understand all the interactions within an ecosystem and considering multiple issues instead of just focusing on a single issue at a time. This approach has been useful when it comes to protection and restoration of estuary ecosystems. Next slide. My current work and research has been focused on estuary conservation, restoration management. My mentor organization that I've been working with is called Tillamook Estuary Partnerships. They are a nonprofit organization located on the north coast of Oregon in Tillamook County. They are part of the National Estuary Program, which is an EPA-based program that works to protect and restore the water quality and ecological integrity of estuaries of national significance. Tillamook Bay was labeled an estuary of national significance in 1994. And Tillamook Estuaries Partnership has been working since that time to protect and restore Tillamook Bay, along with several other estuaries found within Tillamook County. Next slide. Organizations like Tillamook Estuaries Partnership have learned they need to address multiple issues and look at the whole picture when it comes to restoring and protecting estuarine systems. This means that they understand what might be happening in terrestrial areas upstream or out in the ocean, and we'll also have to address those issues as well to protect estuaries. This means reducing pollutants that might be occurring inland from running into the estuaries, fixing or removing infrastructures that might impede the movement of fish species trying to spawn, addressing the water quality, restoring native plants and removing invasive species, along with addressing issues of rapid climate change and collaborating with multiple organizations and agencies to reach their goals of protecting and restoring the estuaries and surrounding watersheds in Tillamook County. Next slide. According to a study discussed in the article titled Depletion, Degradation, and Recovery of Potential of Estuaries and Coastal Seas, when a combination of mitigation measures are used in estuary restoration, there's been a proven success in the majority of restoration efforts in estuary systems. This shows us that restoration of estuary ecosystems can be successful if we look at the whole picture. Next slide. These are just a few references. Next slide. I want to give a big mahalo nui for listening to my presentation. I appreciate the opportunity I was given to be a part of this symposium and to speak about the importance of estuaries. If you need or want to contact me with any questions or comments, my email is listed on the slide as norbom@hawaii.edu. Mahalo.
Thank you so much, Sarah, for ending us with a great presentation. And Sarah will be around for a few minutes if anyone has any questions. All right, well, if any questions pop up, you can throw them into the question and answer box and Sarah will be able to answer those for you. It is now time for our lunch break. So we will be returning at about 12:55 to get us started again and to promote all people who are presenting in the fourth session to panelists. So thank you for joining us for the morning session and we will see you back here in about 50 minutes.
I have to go again.
You have to start again now, yes.
Start again. All right. Well, thank you for having me this afternoon, everybody. No, sorry.
So Tim will take any questions that you type into the question and answer box. We'll give you guys a minute to get those in there. And if we are not able to answer them for you, Tim will be able to type in the question and answer box. Again. All right, looks like we have no questions so far, but again, if you want to throw those, oh, we have one. Out of curiosity, what was done with the fish after analysis?
Most of the fish either ended up being donated to local organic farmers where they were turned into fertilizer. I Did the same for my avocado tree a couple of times. But most of them were donated to local anglers. Roy are generally not consumed because of fears of ciguar toxicity. So yeah, eating them was kind of out of the question.
Thank you again, Tim. It looks like it's time to move on. Okay, next up we have Kaylani Bonis Erickson. She is a TCBES graduate student at UH Hilo.
Aloha, I'm Kaylani Bonis Erickson, and I'm a graduate student in the TCBES program. My master's research project that I'll be sharing with you all today is on identifying patterns in demography, community composition, and 3D structural complexity on coral reefs in Papahanaumokuakea Marine National Monument. Next slide, please. Coral reefs are one of the most productive and important ecosystems in the world, and they provide the habitat structure necessary to support high levels of diversity and abundance of reef organisms. As global anthropogenic stressors and disturbances increase in severity, it's critical to identify and track colony, community, and structural reef characteristics that support resilience and resistance in corals. Next slide, please. My research objective is to track changes in coral demography using coral reef plots in Papahanaumokuakea Marine National Monument mapped at 2 time points, and also to determine how these changes in coral demography exhibit dependencies with genus, patch size, surrounding reef complexity, and surrounding community composition. Next slide, please. To conduct this study, I collaborated with a group of undergraduate marine and data science students at UH Hilo, and we used coral reef photogrammetry data from 3 islands in the monument: Pearl and Hermes, Lisiansky, and French Frigate Shoals. We analyzed demographic transition data from 15 sites across these islands. Next slide, please. So what are coral demographic transition events? Over time, corals can undergo fission when a coral patch splits into 2 or multiple patches, fusion where 2 or more patches fuse into 1 patch, mortality, recruitment when a new coral settles onto the benthic substrate, shrinking, or growth. Next slide, please. So how do we track coral transition events through time? Next slide, please. We use 3D structure from motion photogrammetry, which is a method of generating high resolution, 3-dimensional reconstructions of coral reef habitats. And this method involves taking overlapping images of the benthic substrate from a 2D camera to produce a high resolution 3D model of the habitat. And this is shown in the top image. We created high resolution georeference photomosaics, which are called orthomosaics, shown on the bottom image, as well as digital elevation models from the 3D models to determine demographic transition events, 3D habitat complexity, and coral community composition over time. Next slide, please. For every site, we align coral reef orthomosaics from different time points, such as 2016 and 2017, shown on the image to the left, and we randomly distributed circular plots around the overlapping area shown in the top right image. And as shown in the bottom right image, we traced all the live coral within these circular plots and linked the same corals from time point 1 to time point 2 and recorded if a coral died or if recruitment occurred. So this slide also shows the incredible resolution that allow us to trace even the smallest of corals to a centimeter scale. Next slide, please. From all of this data processing and analysis, I was able to derive the total proportions of each transition event out of a total of 2,409 coral transition events. As you can see here, the greatest proportion of coral patches traced underwent growth and recruitment. Next slide, please. And this graph shows the proportion of all patches in all 3 islands that underwent transition events. with proportion on the y-axis and island on the x-axis. And you can see that French Frigate Shoal had the greatest proportion of coral patches that underwent growth. Lisiansky had high proportions of coral recruitment and growth, and Pearl and Hermes had the greatest proportion of mortality and recruitment. Next slide, please. I perform probabilistic modeling to understand the likelihood of a coral patch undergoing a transition event given its genus, patch size, surrounding reef complexity, and composition. Today, I'll just share with you my results for the mortality modeling. So graph A to the left shows the probability of a patch undergoing mortality given its starting patch size, with probability on the y-axis and starting patch size on the x-axis. As you can see, the probability of mortality decreases significantly as coral patch size increases. Graph B to the right shows the probability of a coral dying given the surrounding surface complexity of the reef, with probability on the y-axis and surface complexity on the x-axis. So the probability of a coral patch dying decreases as the structural complexity of the surrounding reef increases. Now, I did this type of analysis for all other demographic transition events, so you can tune into my thesis defense likely next month for the rest of my results. Next slide, please. I'm still analyzing my data right now, but from this, we can see that coral patches in highly complex reefs are less likely to die, and smaller coral patches are more vulnerable to mortality. Thus, highly complex reefs and reefs with smaller coral colonies should be prioritized for conservation efforts here in Hawaii and globally. We have done this work for only 2 time points, but this work demonstrates the power of these techniques to analyze coral demography. Continuing these analyses for additional time points into the future will allow for identification of important trends associated with resilience or vulnerability of coral reefs to environmental stressors like climate change. Identifying these trends in growth, shrinking, mortality, recruitment, fission, and fusion among different reefs in the Northwestern Hawaiian Islands is critical for projecting the future state of reefs for stakeholders and managers of marine areas. Next slide, please. And with this, I'd like to say mahalo to the UH Hilo Ikewai program, NOAA, Dr. Tom Oliver, Dr. John Burns, Dr. Grady Weinberg, and everybody else who has been helping me in this project. And I'd also like to thank everyone who put together this symposium today and yesterday. And if anyone has any questions, I don't know if I still have time.
You're just about done with time, but if anyone has any questions for Keilani, I'll keep her as a panelist so she is able to answer any questions that may come up in the question and answer box. Thanks, Keilani. All right, next up, we have Amanda Naveen, who is a TCBES graduate student at UH Hilo.
Mahalo Carm and aloha kako. Again, my name is Amanda, and I'm going to tell you about my TCBES master's thesis research investigating the role of the gut microbiome in susceptibility to avian malaria in Hawaiian honeycreepers. Next. Hawaiian honeycreepers are a prime example of adaptive radiation, or the rapid diversification of species from a common ancestor. It is hypothesized that a single finch species colonized the Hawaiian Islands 6 to 7 million years ago and evolved into more than 50 honeycreeper species with a fantastic array of morphologies and behaviors. Next. Unfortunately, Hawaiian honeycreepers are also a prime example of how anthropogenically introduced disease to naive ecosystems is a leading cause of modern extinctions. Today, there are only 21 honeycreeper species left, 11 of which are listed as critically endangered by the IUCN. Only 2 honeycreepers are listed as species of least concern, and we'll come back to them shortly. Next. While no single threat is entirely responsible for the decline of Hawaii's birds, the largest modern threat by far is avian malaria, caused by the blood parasite Plasmodium relictum. P. relictum reproduces in avian red blood cells, and when the parasite load becomes too great, the cells burst, causing the bird to become anemic. Next. It is difficult to say when malaria first arrived in Hawaii, but it only became a serious problem upon the introduction of its vector, the southern house mosquito, in 1826. With the spread of avian malaria now facilitated by mosquitoes, we began to see highly elevated extinction rates among Hawaiian honeycreeper species. Next. Unlike mainland species, which have co-evolved with avian malaria for thousands of years and have low mortality rates, honeycreepers evolved in the absence of the disease. Because of this, they either never developed or lost any innate immunity to malaria and suffer heavy mortality rates when exposed. Next. Most of today's honeycreeper species are only persisting in high elevation refugia, or safe zones from disease, shown here in purple, where the mosquito population dispersal and the development of malarial parasites are limited by temperature and rainfall to less than approximately 1,500 meters, shown in yellow. However, as global temperatures rise due to climate change, malaria-carrying mosquitoes may expand into higher elevations, diminishing the amount of disease-free habitat for honeycreepers like we see happening as we move from the left image to the right image. In the coming decades, we may see a rapid loss of avian refugia, and with them, the loss of many more native honeycreeper species. Next. Successful honeycreeper conservation will require developing and implementing vector control strategies, such as the bacterium Wolbachia and/or gene drives to control mosquito populations, reducing the amount of habitat available for mosquito reproduction, and/or active destruction of mosquito populations through the use of pesticides. Next. As well as host protection strategies, such as restoring forest habitat at high elevations to give honeycreepers space to expand, improving and/or implementing captive breeding programs for the most at-risk species, encouraging host immunity to malaria through genetic-based strategies, and/or developing prophylactic probiotics. These probiotic-based strategies are where my interests lie. Next. There's building evidence to suggest the collection of microorganisms within the intestinal tract, or the gut microbiome, has a strong influence over host health and fitness. Recent experiments with mice revealed a strong connection between gut microbiome composition and malaria parasite resistance and disease severity. Next. Remember those two honeycreepers that the IUCN listed as species of least concern? That would be these two, the Apapane and Hawaii amakihi. These two honeycreepers are the only two found throughout their historic range, including in areas of high malaria prevalence, though Apapane are found at much lower densities. Apapane and amakihi show variation in malaria mortality rates across an elevational gradient, with lower elevation populations showing greater survival than high elevation populations. This suggests that the increased disease pressure at lower elevations has selected for the evolution of some immune strategies. My hypothesis is that one of those immune strategies is the evolution of a gut microbiome that can confer resistance to malaria. Next. To test this hypothesis, I used genetic techniques to characterize honeycreeper gut microbiomes and assess two research questions. First, does P. relictum infection intensity co-vary with honeycreeper gut microbiome composition? Next. And second, are there specific microbes within the honeycreeper gut microbiomes that are associated with lower P. relictum loads and thus have the potential to confer resistance to malaria to the host? Next. To answer these questions, I analyzed bird gut microbiomes from cloacal swabs, which are like anal swabs, and parasite loads from blood samples of two focal species found across the island of Hawaii, the Hawaii amakihi and the warbling white-eye. These samples were collected by the USGS Avian Malaria Genomics Research Project field crew and myself. Next. As I've mentioned, amakihi are non-endangered native honeycreepers that show mixed mortality to malaria across an elevational gradient, ranging from as low as 3% fatality at low elevations and as high as 68% at high elevations, where exposure to malaria is much lower. I was able to generate microbiome composition data for 189 amakihi. Next. Warbling white-eyes were included in this study because they are a non-native species that is immune to malaria mortality and are ubiquitous throughout Hawaii forests. This means that they can serve as a control to filter out differences we might see in microbiome compositions due to between-site variation as opposed to malaria infection status. I was able to extract microbiome compositions from 175 white-eye samples. Next. These samples were collected from 16 sampling sites that varied in elevation across 6 regions of the island of Hawaii. The approximate locations for these regions are shown on this map. Samples were grouped by region to identify any microbiome variation that may have been introduced by geographical factors instead of by disease factors. These regions were Ka'u with 4 sites, Kona and Mauna Kea, each with 1 site, Puna and Pu'uva'ava'a, each with 2 sites, and Volcano with 6 sites. Note that for Puna, I only had a sample size of 8 birds. This region of Hawaii has been heavily impacted by natural disasters and anthropogenic disturbance, which has taken a heavy toll on Amakihi populations in that region. There were few birds available to sample. Therefore, Puna samples were removed for parts of my analysis. Next. To quantify a malaria infection status, P. relictum infection intensity was evaluated via qPCR for each blood sample. qPCR is a method for quantifying how many copies of a specific segment of DNA is present in a sample, and by targeting P. relictum DNA, we can estimate the parasite load in the blood. These samples are being processed by a collaborator at the Northern Arizona University and have not yet been completed. Next. To characterize the gut microbiomes, I extracted DNA from the cloacal swabs and used a technique called 16S rRNA gene sequencing. This is a technique that amplifies a specific region of DNA that is found in all of the microbes of the gut, but is variable enough for us to be able to identify which species of microbes are present and in what abundances. It is not always possible to identify microbes down to the species level, so this technique classifies them into operational taxonomic units, or OTUs, which are groups of microbes whose 16S rRNA genes are 97% identical. I could then use these taxonomic units to generate information on the composition of the microbiome, such as microbe species richness, meaning the total number of species, and the Shannon diversity indices, which combine species richness data with evenness of abundance for each taxonomic unit. Next. To assess microbiome variation, I used R to analyze the data under a permutational multivariate analysis of variance, or PermaNova model. Briefly, this model is used to compare within group to between group variance, and I will use it to determine if the variation we see in the microbiome composition is explained by variation in species, sampling region, and/or infection status, so whether or not the bird shows any signs of infection. I also used a linear regression model to assess the effects of elevation and parasite load on microbiome composition. At present, I have completed gut microbiome characterization, but as I mentioned, I'm waiting on malaria data from a collaborator. Therefore, I only have preliminary results to share today, which are nonetheless interesting. Next. My preliminary analyses indicate that species richness within gut microbiomes varies significantly between some regions, but not all regions, and does not significantly vary between Amakihi and white-eyes. This plot displays species richness counts on the y-axis, the sampling region on the x-axis, Amakihi samples in dark colors, and white-eye samples in light colors. The boxes indicate the interquartile range, and the lines through them indicate median richness value for each population. The letters at the top of the plot indicate which populations are grouping together based on a pairwise comparison of their means. Next. You can see that for every region, Amakihi and white-eye samples are grouping together, as indicated by consistently having the same letter combination. This means that gut species richness does not differ significantly between the two species. Next. However, species richness does vary between some of the regions. Ka'u, Kona, Puna, and Volcano all have an A, indicating that they aren't significantly different between any given pair within this set. Next. But Mauna Kea populations have significantly higher gut species richness than any other region other than Pu'uva'ava'a, as indicated by the C. Next. I found a similar pattern when I looked at microbiome Shannon diversity indices, which again factor in species richness and evenness. Again, we do not see a significant difference in the diversity of the microbiomes between species, and the regions are grouping together in the same pattern as we saw for species richness. Next. An important thing to keep in mind is that although I did not find significant differences in the species richness or diversity of the gut microbiomes between Amakihi and white-eyes, this does not mean that differences do not exist. This plot shows you the proportion of the top 20 most abundant microbial genera found within the gut microbiome of each species for each region. Not only do we see regional variation, but there may also be some consistent variation between the species. Next. For example, E. shigella appears to be consistently more abundant in white-eyes than in Amakihi. So while overall diversity levels may not vary between species, microbial community assembly might. These interpretations need to be made lightly, however, as I have not yet fully analyzed these data. I would also be skeptical about any interpretations made around the compositions of the Puna populations due to the low sample size from this region. Next. Because malaria prevalence is linked to elevation, and until I get the malaria data, I've been thinking of elevation as a loose proxy measure for parasite burden. For my elevation analyses, I have removed the samples collected in Puna in order to avoid bias introduced by small sample sizes. This plot shows gut microbiome species richness on the y-axis and elevation in meters on the x-axis, with Amakihi samples shown in red and wide-eye samples shown in blue. The trend lines are based on a non-parametric linear regression model, and the shaded bands are the 95% confidence intervals. We can see that species richness stays relatively constant in wide-eye microbiomes as elevation increases, which may not be surprising when we consider that they are resistant to malaria infection. More interesting is the pattern we see in Amakihi, which seem to have the lowest microbiome species richness at mid-elevations. Next. Both species display similar trends in their microbiome Shannon diversity indices across an elevational gradient. These trends may be related to gut microbiome species turnover during malaria infection, as previous studies have shown that malaria infection reshapes gut microbial composition in mice. We will know more about this once the malaria data comes in. Next. Taken together, these results indicate that there are substantial differences in the gut microbiomes of Amakihi populations sourced from different regions of Hawaii and across an elevational gradient. There are numerous factors that can influence gut microbiome compositions, including diet, age, geographic location, etc. And I'm excited to get the P. relictum data to determine if malaria infection could be one of those factors in birds. Any information we find in Amakihi will likely apply to many endangered honeycreepers, as they are all closely related species. Next. Determining which, if any, bacterial species are associated with increased protection from malaria is the first step in assessing the potential of probiotic-based conservation strategies to help mitigate the honeycreeper extinction crisis. Prophylactic probiotics have recently garnered scientific attention for their potential to lessen the burden of malaria on human health, but they are also an attractive option for treating wild animal populations for several reasons. Due to the logistical difficulties of capturing and injection vaccinating whole animal populations, traditional vaccines are not a feasible method for protecting honeycreeper populations against disease. However, probiotics that could be administered to honeycreeper populations in the form of food supplementation is an appealing way to circumvent such issues. Probiotic supplementation could also be incorporated into captive breeding programs in order to cultivate increased malaria immunity in birds that are to be released into the wild. Next. This project has been a massive undertaking and would not have been possible without the help from many individuals and the collaboration of many organizations. I want to thank too many people to list by name, including those on my thesis committee at the Smithsonian Institute Center for Conservation Genomics, my collaborators at NAU, and of course, all my friends in the Lohe Lab, in CGRG and TCBES. Next. I also want to thank the funders of my research, the Smithsonian Institute Graduate Research Fellowship Program, the Yoshimoto Foundation, and the American Ornithological Society. Next. And with that, I will take any questions.
Thank you, Amanda. It was such a great presentation. We'll see if anyone has any questions for you. All right, looks like we have some questions here. Is there any way the gut microbiome could be passed to offspring?
That's a really interesting question. It's something that's actually being investigated by some of my collaborators at the Smithsonian. They're looking at whether or not adding microbes to eggs can increase the gut microbiome species richness of the offspring after they hatch. That's something that hasn't been investigated previously, but we are currently looking into. Obviously, in mammal systems, it's very different because they have live birth, but with birds, the microbiome of the eggshell might actually be important. So that'll be an interesting study when it comes out.
And last question for you, Amanda. Can you comment on the relationship between microbiome and infection in terms of cause versus effect?
So that's a little bit difficult because it's a complicated system of interactions between host, microbiome, and disease. While the microbiome can shape disease infection, and infection can also shape the microbiome. So it's a little bit more complicated than just cause and effect. And this is a relatively new discipline for understanding disease interactions. So at this time, it's a little bit harder to explain, but I can definitely go into it more detail if you'd like, JP. Just shoot me an email.
Thanks so much, Amanda.
Thank you.
All right, next up, we have Olivia Jarvis, who is an undergraduate student at Hilo.
Hello, everyone. My name is Olivia Jarvis, and I'm an environmental science undergraduate student at Hilo. And this semester, I worked on a project with the Mega Lab that assessed the extent of a weather buoy damage event at coral reefs in Lisiansky Atoll. Next slide, please. So NOAA Weather Buoy 3D61 was deployed at station 51001 in 2016, just northwest of Kauai Island, and in March 2018, it went adrift. Next slide, please. And 6 months later, it was reported inside of the Marine National Monument. Several months after that, it drifted towards Lisiansky Atoll, and it stopped at 3 locations along the way for multiple days. So in this image, the orange line kind of shows the trail the buoy took to get to Lisiansky Atoll, and the green dots are the 3 sites that the weather buoy stopped for multiple days. Next slide, please. So a team of divers about 6 to 8 months later were able to get out to the northwestern Hawaiian Islands and survey these locations. So the first site, Site A, the weather buoy stopped for 5 days, and the second site, Site B, the weather buoy stopped for 84 days. And in these 2 locations, there were no obvious damage, likely because the chain of the weather buoy was shorter than the depth of these sites. However, in Site C, the buoy was hung up for about 22 days. And this site, we saw relatively large amount of reef damage. Next slide, please. And so 2 scuba divers identified damage on the side, ledge, and top of the reef. They were able to take images that were later reconstructed as 3D models. And on the left, this is the side of the ledge where damage was done. And on the right-hand side, this is the top of the ledge. And these are the orthophoto mosaics that were constructed. Next slide, please. So we classified the types of damage into 4 categories: cracking, breakage, abrasion, and abrasion with algal growth. And these are kind of images of examples of what that would look like in the orthomosaics. Next slide, please. So these, with ArcMap, we were able to digitally annotate the damage types. So we identified the areas in blue as abrasion, the areas in green as abrasion with algal growth, pink areas as cracking, and yellow areas as breakage. Next slide, please. And so we saw very similar trends among the 2 sites, or the 2 plots. Most common type of damage was abrasion, followed by abrasion with algal growth, cracking, and breakage. And next slide, please. And similar in plot 2. Next slide. And so we were able to come up with some conclusions and assumptions about the weather buoy damage. So we concluded that the abrasion was likely caused by the chain connected to the weather buoy as it scraped, encrusting and mounding corals. The algae that grew on top of some of these abrasion sites were all turf and neomerus green algae. Breakage in plot 1 was a dislodged substrate with surrounding Parietes lobata colonies, and breakage in plot 2 was mostly Parietes compressa branches that kind of got knocked off by the buoy and the chain. This image here is actually a crack right next to the ledge, and this is where we believe that the buoy was hung up. So, and we saw cracking plates mostly along this side of the ledge. So we believe that this was due to some of like the vertical movement from swells while the buoy was there. And so we see the most extensive damage done along the side of the ledge where the buoy's hung up. And we believe once it got distangled on top of the ledge, we saw kind of spotty damage. So that's kind of where, as the buoy drifted towards Lisiansky Atoll, kind of where the damage was done. As for recovery, corals take a long time to regrow, so we're likely to see more algal growth before coral colonies regrow. And we hope this assessment brings awareness to the risk of buoy grounding and damage done to coral reef habitats by buoys gone adrift. Next slide, please. So with that, thank you to EKVI, the Megalab, Dr. John Burns, Dr. Asuko Fukunaga, and Kylie Pusoke for giving me the opportunity to be a part of this project and helping me along the way. And thank you to TCBES for holding the symposium and allowing me to talk today.
Thank you so much. We will see if anybody has any questions for you, Olivia. All right, Olivia, one question here. How common is buoy grounding and similar events?
Yeah, this is interesting. So I didn't know this before the project, but I guess this is quite common for buoys to go adrift, kind of from storms or large wave swells. It's pretty common for them to kind of get dislodged and go adrift. I'm not too sure how often coral reefs are surveyed after damage, but I know this is one example of a surveyed damage site.
Thank you so much, Olivia. Next up, we have Carson Green and Rachel Willard, who are undergraduate students at UH Hilo.
Hello, everyone. My name is Carson Green, and I'll be presenting today with Rachel Willard on some research we did last summer through the EKVI program. The title of our presentation is Down to Digitize Tracking Vitality of Corals in the Northwestern Hawaiian Islands through Geospatial Software. Next slide, please.
Okay. Carson and I are some of the interns under Kaylani's project, so we apologize if there's anything repeated, but you should now be very familiar with our study. We'll start with what corals are and why we study them. Corals are unique colonial invertebrates made of thousands of tiny individual polyps. Most hard coral species rely on the symbiotic relationship with zooxanthellae in their tissues for nutrient production and can also capture prey using their nematocysts or stinging cells. Corals can reproduce both sexually and asexually, and their secreted calcium carbonate exoskeletons are used to build up reefs. Coral reefs cover less than 1% of the ocean floor, but are home to nearly 25% of all marine life and create rich and diverse ecosystems. They are responsible for coastal protection and carbon fixation and are economically important, providing jobs, food, opportunities for recreational activities, and are also used in biomedical research. Next slide. Stressed corals are prone to expelling their algal symbionts, causing them to bleach. A number of factors are responsible for the mass mortality rates in corals we are seeing worldwide. In the past 30 years, 50% of coral reefs have died, and the projection for the future is grim, but not without hope. Ocean pollution, increasing temperatures, ocean acidification, disease, and hypoxic events such as harmful algal blooms are major global stressors, and local stressors include overfishing, coastal development, and invasive species. Next slide.
So some of the things we wanted to get from this study was to build orthomosaics taken from photographs in the northwestern Hawaiian Islands. We also wanted to be able to compare the reefs from 2016 to 2017, and mainly we wanted to look at reef characteristics in order to determine winners and losers. And by this we mean coral characteristics, which led to certain species being resilient or not in the face of disturbance. And identifying which species are thriving, experiencing growth, and recruiting can determine which species are most resilient in these changing conditions. We also wanted to understand specific coral species' ability to adapt to changes in conditions due to disturbances, which is very useful in conservation and restoration of coral reefs, not only in the northwestern Hawaiian Islands, but globally. We also looked at bleaching, and examining the extent and severity of this coral bleaching gives us a better understanding of how prospective bleaching and mortality can be avoided. Identifying which species are experiencing high rates of mortality can give insight into the cause of decline and what characteristics are unfavorable with changing conditions and what effects this may have on the entire coral reef system. So overall, understanding the vital rates of coral species can provide further information pertaining to the comprehensive demography of coral reefs in the northwestern Hawaiian Islands. Next slide, please.
Okay. Our study looked at coral colonies around 3 islands in the Papahanaumokuakea Marine National Monument in the Northwest Hawaiian Islands. The monument spans over 1,200 nautical miles and hosts more than 7,000 species, 25% of which are endemic to the islands. Over 2016 and 2017, images were collected from 6 Lisiansky sites, 6 French frigate shoal sites, and 3 Pearl and Hermes atoll sites. The reefs around these islands are relatively healthy and remain undisturbed. This provides an ideal natural laboratory to study how reefs respond to changing environments when protected from local anthropogenic influences. Next slide.
So to begin our methods, we collected images at reefs using 30-meter transect lines, which were laid on the survey site and then surveyed by scuba divers, which you can kind of see in the right picture. After each of the surveys, the divers collected the images of the reef that were overlapping about 70 to 80% along the transect, and then we used structure from motion photogrammetry to stitch together orthomosaics, which Rachel will talk about more in the next slide. Next slide.
Yeah, so 2D orthomosaic models were created using structure from motion photogrammetry and then imported, overlaid, and aligned in geospatial software ArcMap. Each plot had 20 subsample circuits randomly assigned with consideration to graphic buffer and distortion. Coral colonies were fine traced or digitized using the editor and create feature tools in order to create unique polygon shape files of live tissue patches. Carson and I spent a good chunk of our time during our internship digitizing these plots, always down to digitize. For standard quality control, coral colonies exhibiting 75% or more total surface area within the circrat, or corals exhibiting the center of their colony within the circrat for at least one of the 2 sample years were always digitized in both sample years. Next slide, please. Each patch had a unique ID to identify and link vital rate transition information over the 2 years, noting if fission, fusion, mortality, or recruitment had occurred, and used as a means to compare topographic complexity data. Bleaching extent and severity were also noted. You can see in the large Acropora species, and Circrat 3 is starting to see some bleaching in 2016. And by 2017, rapid tissue loss led to fission of the colony. Next slide. So 3D structural characteristics were generated in ArcMap, which has specialized spatial analysis functions and then quantified using R. ArcMap is able to calculate real distances from orthomosaics, enabling us to extract factors like slope, curvature, vector ruggedness, and surface complexity for topographic analysis. Next slide.
So ArcMap wasn't the only software we used when analyzing the orthomosaics. We also used CoralNet, which was a little quicker than digitizing an ArcMap. So what CoralNet did is each of these orthomosaics was assigned 1,000 sample points that were then manually labeled by us. So any point that landed on a coral colony was then classified down to its genus and its morphology. And all the other points were labeled as stuff like microalgae, maybe mobile fauna, turf algae, or some other abiotic feature. So this data was then exported and analyzed in R, looking at things such as total coral cover, diversity, and abundance. Next slide, please.
Yeah, so data extracted from CoralNet allowed us to look at differences in coral diversity, coral abundance, and percent coral cover by location. This plot depicts coral diversity between French frigate shoals and Lysianski, and shows that coral diversity was not statistically different between the two. The dominant species at each location was Porites, Acropora, Montipora, and Fossilopora were prevalent as well at these sites. Next slide. This plot shows coral abundance between sites, and we did find that French frigate shoals had a much greater coral abundance than at Lysianski. Next slide. And that French frigate shoals showed significantly higher values of percent coral cover than Lysianski. Lysianski had faced a mass bleaching event in 2014 and is still recovering from large-scale mortality, while French frigate shoals is dominated by Acropora species with a morphology that tables out horizontally and likely accounts for the higher percent coral cover. Next slide.
So here's some of the vital rates for French frigate shoals. This was site 21. If you look on the right, we can see kind of some of these vital rates. First, we have the plus sign, which is recruitment, the yellow X, which is mortality, the growth in green, and then shrinkage in blue. The upside down triangle is fission, right side up is fusion. For the top plot, we're looking at Acropora species. And for overall trend, we see a lot of growth. Not as much mortality, only 2 there, and a lot of recruitment, versus where if we were looking at the bottom plot for Porites species, we see that over the time, there is a lot of fusion events, but there is also quite a bit of mortality in those little yellow X's at the bottom. So it seemed like for at least French frigate shoal 21, that the Acropora species coral had a lot more positive changes, such as growth, fusion, and recruitment, while the Porites species had a lot more negative changes, including that great deal of mortality, shrinkage, and fission. Next slide, please. This is another vital rates plot for Lysianski. This time it is only looking at Porites species coral. And it's a little different here in Lysianski. We can see that there's actually only 1 mortality and 1 fission event. So overall, there's a lot of fusion and growth for the Porites species here at Lysianski 12. So this is very different from French frigate shoals because it's all positive pretty much, and nearly all colonies experience some growth or fusion. Next slide.
Overall, we found that all sites exhibited similar variability in coral community composition, and that French frigate shoal sites had significantly more coral cover and diversity than Lysianski. Sites also showed variabilities in vital rates. Some species and locations exhibit more positive trajectories in growth and recruitment compared to others. This is an ongoing study in the Mega Lab headed by Keilani Bonis Erickson, and the verdict of who are the winners and losers is waiting to be reached. Research like this aims to understand changes in coral vitality and in identifying their stressors with the potential for future protection and conservation. Next slide.
I just wanted to thank UHEO's EQI program, Dr. John Burns, who headed our research, Kaylani, who's still working on this, Kylie, Alex, all the other EQI interns who worked on this project, and all the Mega Lab members who also helped out. Next slide. Any questions?
Thank you both so much. And if anyone has any questions, you can throw them into the question and answer box. So how long does it take to digitize a single plot?
But yeah, that's a great question. I mean, it definitely depends on the plot. I've had some plots that didn't have much coral or didn't have much going on. You know, it took like a couple days, maybe even less. But I also have a plot, for example, I'm working on right now, and the Mega Lab that I've been working on for maybe more than 2 months, just trying to get all these tiny species of coral. So it really depends on the plot. It can vary, but it can take a very long time to get everything.
And during this study, we did the circrats in the site, so we only did like 20 circles in the plot, which did save time, but a full plot takes maybe 60 hours.
Yeah, a long time.
Another question we have here is, are there site characteristics that differ between the two sites that might explain the differences you see?
I think overall we were seeing like French Riga had a lot more cropper species, and that might explain some of it. But it's hard to tell. We would probably need to look at a couple other factors to see overall. But I think that's one that could explain some of the differences between the two sites.
The morphology of different corals.
Mm-hmm.
Another question, on your study objective slide, you had a photo of a Leptostria coral colony. What month was that photo taken and where was the colony located?
We took
I'm
these
not sure
photos
actually.
from like a collective drive, so I don't know.
Okay.
Yeah, we might have to find out later, and email you. I definitely don't have that one off the top of my head. Good question though.
Thank you guys. We have 3 minutes until our next presentation. If anyone else has any other questions. And we have one. If you could have included one more variable or method in this research to further expand your findings, what would it be?
Oh, that is a good question.
I think definitely if we could
I
factor
mean,
in ocean acidification or something that is a big impact.
yeah, that's definitely one. Yeah, I think that would definitely be cool, and especially like if we had more years as well. I think that would help for some of it, but we didn't have the data for all of that. But yeah, I think ocean acidification would be a really cool one to look at.
Great, thank you both. We will start the next presentation at 2:10. All right, we're ready to get started with our next presentation. We have Jessica Glasner, who is a TCBES graduate student at UH Hilo.
Mahalo, Carmelita. Aloha, everyone. My name is Jess, and I am a TCBS grad student interning with the Nature Conservancy's Palmyra program to support their efforts on coral reef resilience. Coral reefs support incredible biodiversity, provide important biological services, and contribute millions to the local economy through fisheries, storm protection, and tourism. In the Kumulipo, the Hawaiian creation chant, the ko'a, or the coral polyp, was the first organism created. The Hawaiians recognized coral as the building block for the rest of the reef ecosystem. We each also have our own personal connection to the coral reef. And I think that I can speak for us all when I say that the importance of protecting and stewarding our reefs runs deeper than just maintaining the services that they provide. Next slide. Unfortunately, coral reefs are disappearing at an alarming rate. Global climate change is causing sea surface temperatures to rise, and in the tropics, these warming temperatures are causing corals to bleach or lose their symbiotic algae that provides them with the majority of their food, causing them to starve. In many cases, this can lead to coral mortality. Models predict that bleaching events are going to become more frequent and severe in the near future as sea surface temperatures continue to rise. We know that coral reefs are going to bleach, so how do we keep them alive during a bleaching event so that they may recover and persist through climate change? My project addresses the urgent need for a new management action that could help corals survive through bleaching events. Next slide. The 2015 to 2016 global thermal stress event impacted coral reefs throughout the Pacific. Average coral mortality was 30%. Palmyra, an atoll in the Central Pacific, was a notable exception. Although 90% of live corals at long-term monitoring sites at Palmyra Atoll bleached during this event, there was no reduction in live coral cover on Palmyra's shallow reef terrace from 2015, when the bleaching began, to 2017, when the bleaching stopped. So what makes Palmyra's corals so much more resilient in the face of thermal stress? They're exposed to nutrient-rich water flowing from the atoll's lagoon out to sea. Next slide. Palmyra has 11 species of seabirds that forage in pelagic waters and come back to nest and roost on the atoll. Their guano washes off the atoll and into nearshore waters, linking the pelagic ecosystem to the coastal ecosystem and providing reefs with ample nutrient subsidies. This nutrient pathway has been linked to coral reef resilience. Palmyra also has a predator-dominated reef system, and sharks are another important vector of pelagic nutrients to coastal waters at Palmyra by consuming pelagic prey and excreting their waste onto the reef. Next slide. So, how does seabird guano and shark excrement help corals? These nutrients increase primary production, or phytoplankton biomass, which is the base of the food chain and feeds and supports animals from corals to manta rays. Although corals are known for obtaining food from their symbiotic algae through photosynthesis, they can also obtain up to 100% of their energy requirements by feeding directly on plankton. This is particularly important during bleaching events when they lose their photosynthetic symbionts. Corals that can feed on plankton have been found to be better at surviving through thermal stress events, and it's believed that this contributed to the high survival rate of Palmyra's corals through the severe bleaching in 2015 to 2016. Next slide, please. In contrast to Palmyra, most inhabited islands like Hawaii have seabird and shark populations that are below their natural densities. This has been caused by human activities such as introduced predators and overfishing. The removal of these vital species has resulted in a disruption to the nutrient cycle and the services that they provide. Corals in the Pacific exhibited up to 90% mortality in the same 2015 to 2016 bleaching event, indicating the urgent need for management efforts to help these corals through future thermal stress events. Next slide. We are currently in the process of looking for contributors to help fund this project. An experiment will be conducted in the lab to explore the possibility of using pelagic fish waste from local fishing activities, an ample and available resource, to create a solution with similar chemical properties to guano. The fish solution will be added to aquaria filled with seawater to measure if there is an increase in phytoplankton biomass. Next slide, please. Next, we will evaluate if corals can utilize the plankton-enriched seawater through increased temperatures and measure coral growth and mortality. Stable isotope analysis of coral tissue, their endosymbionts, the plankton, and the fish solution will inform us if the corals are utilizing the increased nutrient resource we're providing them with. On populated islands throughout the Pacific, management efforts focused on seabird habitat restoration and shark conservation are underway. These are vital and must continue. However, it will likely be decades supplying reefs with significant natural nutrient subsidies. Next slide. Inspired by Palmyra, this project will inform management actions that improve resilience to climate impacts throughout the Pacific. We are gathering input from experts in different fields to help advise this multidisciplinary project that crosses from Mauka to Makai. The TCBES program is a great place to continue this interdisciplinary work, and I would like to extend an invite to anyone who is interested in this project to please reach out so that we can continue the conversation and build upon the incredible amount of knowledge within this community as we work towards these conservation goals. And next slide. And with that, I would like to extend a big mahalo to my mentor, Chad Wiggins, and the rest of the Palmyra team and the Hawaii chapter of the Nature Conservancy, everyone who has provided their expertise and guidance on this project so far, as well as my TCBES cohort and advisors for their support, and to all of you for listening, and would love to take any questions or comments.
Great job, Jessica. We'll see if any questions come in. All right, we have a question here. How are seabird nutrients different from nutrients from fertilizer or runoff?
That is a great question. And that's definitely an issue that places with people are facing. Definitely here on the Big Island, we're having a lot of conversation around the sewage pollution and agriculture, fertilizer runoff, golf course fertilizer runoff. And I think one of the main differences is the nutrient identity. So the types of nutrients that are in seabird guano versus some of these fertilizers or sewage. Namely, seabird guano is made up of a lot of ammonium and phosphorus, which have been found to be beneficial to coral reefs, causing increased growth rates and more resilience to thermal stress. Whereas studies on nitrate and some of the other nutrients within the fertilizers are found to be negative to coral reefs decreasing growth rates, decreasing calcification, and causing them to be much more susceptible to bleaching. So it really comes down to the nutrient identity.
Thank you, Jessica. It looks like you have one more question. So if you would like to type it out in the question and answer box, I will leave you on as a panelist so you're able to do that. Thank you. Okay, next up, we have Danielle Wild, who is an undergraduate student at UH Hilo.
Hello, my name is Danielle Wild, and we're talking about the effects of Chondria tumulosa on the 3D habitat complexity of reefs on the Pearl and Hermes Atoll. Next slide, please. So what is Chondria? Chondria is a mat-forming red algae with spinous branches that grows in a tumbleweed-like form, which allows it to detach and travel at large distances very easily. This, along with its growth rate, gives it very invasive-like qualities that have the potential to cover extremely large areas of reef. Though there's no known origin, it was first spotted on a structure from motion model in 2015, right north of Pearl and Hermes, and now it can be seen in football field-sized patches in 2019. In shallow waters, this algae was found on spur and groove reefs, aggregate patch reefs, and hard substrate at inner lagoons between 5 and 70 feet seawater, but its highest abundances were at 30 to 40 feet seawater and 6 to 7 inch mats. Next slide, please. So why do we care? While Chondria has not been confirmed as introduced, its invasive-like qualities and its lack of relation to any known native Hawaiian species indicate that it probably is introduced. The main Hawaiian Islands are impacted by several well-known invasive seaweeds, but the presence of something like Chondria is far less common in the Papahanaumokuakea Marine National Monument, and especially something of this abundance. As I mentioned, its tumbleweed-like growth allows it to detach and move easily, but UH divers have found beneath the detachments of the algae, there has been bare substrate and dead corals, indicating that the overgrowth of this algae may be devastating for the reef. Another concern we're finding is a lack of native grazers upon this algae. Grazers such as parrotfish are constantly feeding on native species of algae to keep them from growing out of control, but no native grazers seem to have any interest in the Chondria species. Next slide. All right, so here's a little map just to get us oriented. On the far right, you can see Big Island of Hawaii, and as you go more towards the northwestern edge, you can see Pearl and Hermes Atoll circled in red. It's also known as Manavai. Next slide. And here's a layout of where many of the sites we surveyed are located. These sites were determined haphazardly, and we used 20 sites for our studies. Next slide. While there's still much research going on with this topic, a few of the objectives we wanted to achieve here were to create baseline data for percent cover of Chondria PHR, survey long-term sites to track changes over years, and describe predictor variables that could drive abundance of Chondria cover. Next slide, please. So how did we get the data to analyze? On the far left, you can see a diver taking pictures of the reef. To create 3D models, we use structure from motion photogrammetry, in which the diver swims back and forth in a zigzag pattern, taking hundreds of photos that can later be put into an Agisoft software and stitched together where they can overlap and create the 3D model that you see on the third picture. From this 3D model, we can extract metrics such as elevation to get like a digital elevation model, as you see on the far right side. And these different 3D metrics that we can extract from the 3D model help us to determine a lot of things because they affect both the diversity and abundance of the reef organisms. So they're really important to understand and to study. Next slide, please. So first of all, we wanted to look at the overall cover of Chondria at Pearl and Hermes. So we have all of our sites on the x-axis, all 20 sites, and percent Chondria cover on the y-axis. As you can see, it's overall pretty low cover of Chondria with the exception of PHR 80 and PHR TC 26, with fairly high cover at both of those sites. Next slide, please. Okay, and then also this is just looking at the basic coral cover at each of the sites. Again, we have sites on the x-axis and percent coral cover on the y-axis. It varies a little bit in here, but overall it's pretty low percent. All of the coral cover is under 20%. And this makes sense because Pearl and Hermes is actually close to the Darwin point threshold, which is a depth limit at which corals are known to drown. So it kind of makes sense that we wouldn't have a ton of coral cover down there. Next slide, please. We also wanted to look at surface complexity at these sites as well. And this varies a little bit as well, but surface complexity is needed for marine organisms to thrive and have a habitat to live in. So we wanted to definitely take a look at that as well. Next slide, please. So looking at long-term sites, certain sites at Pearl and Hermes are able to be visited every cruise, but it all depends on weather, time, and resource availability. Weather is a major factor, as one side of the atoll can be perfectly calm while the other could have 20-foot swells. We're able to gather Chondria data on 4 different sites from repeated time points at 2016, 2017, and 2019. Next slide, please. So first of all, this is looking at our long-term sites for chondria cover. So again, we have our 4 sites on the bottom and then percent chondria cover going up. PHR 33 has no chondria cover. PHR 33 had a little bit of increase in 2019. PHR 42 actually went down in chondria cover, and then PHR TC 26 was one of the main sites we were looking at because it had a big jump, as you can tell, from around 45 to almost 80% chondria cover, which is a lot of chondria. Next slide, please. And then looking at the coral cover and how the chondria affected it, it looks like PHR 33 didn't have any coral. PHR 33 had a slight increase in coral cover, while R42 had a slight decrease. And then that same site of PHR TC 26, where it went up in chondria, it actually went a lot down in coral cover. So it can show the effects of what chondria can do. And I kind of wanted to visualize that for you guys. So if you go to the next slide. This is that same site, TC26 in 2015. As you can see, it's mostly coral covered, coral dominated, with maybe around 20% chondria cover just sparsely throughout. And next slide, please. And this is that exact same site, TC26 in 2017. You can see a lot more of the red-brown algae nearly everywhere on the plot. It's about 50% of the plot is covered in the chondria. Next slide, please. And then this is that same plot in 2019. And now it's around 80% chondria cover, and all of the corals are very little or dead. And so it kind of shows the impact that chondria can have even just visually. Next slide, please. Okay, and then this is the surface complexity over time at the long-term sites as well. Not much change as far as these different sites. PHR R33 did have a slight decrease, but it was due to a different algae growing there. It wasn't due to chondria. Next slide, please. After looking at some of the basic figures, like we just did for the differences between years, we wanted to see if we could find anything specifically driving the chondria. After putting all the predictors into a regression, depth was the only significant predictor that drives the abundance of chondria. So as you can see, we have depth on the x-axis, chondria on the y-axis, and as depth increases, percent cover of chondria decreases. This makes sense a lot because with increasing depth, there isn't enough light to help chondria grow in such invasive ways. So yeah, that was one of the significant things we found. Next slide, please. Future directions. So as I mentioned, this is still a brand new algae species like being discovered. So we want to learn and explore more about every aspect of it to get baseline data of how it even works. This is especially important because it can cause such devastating conditions for native and endemic species. We also want to continue looking at the depth analysis, given the possible correlation that we found here, and see if we could find more information regarding that. Another thing we'd like to do is analyze different habitat types, such as chondria-dominated, aggregate reef, and pavement to determine how chondria affects structural complexity of coral reefs, again, affecting the abundance and diversity of the habitat around it. Next slide, please. I want to give a huge mahalo to all of these people, to Kylie Pascoe, Dr. Heather Spalding, Dr. Atsuko Fukunaga, Dr. John H.R. Burns, Taylor Williams, Bree Craig, everyone at the Mega Lab, and everyone at the TCBES Symposium for having me here. Next slide. And I'll be happy to take any questions.
Thank you so much, Danielle. All right, looks like we have some questions already. Are these all confirmed monoculture mats of chondria for each area? How far can you zoom in these 3D models to check?
So these 3D models are actually really high resolution. We can go as far as 1 centimeter resolution, which is like super, super in depth. I'm not sure if it's confirmed complete monoculture, but it did seem like that was the dominant species at most of the sites that we were looking at. And as I said, like the R33, it had a different type of algae growing there. So we are recognizing different types of algae as well. But this one just had the invasive properties and was growing very extremely fast.
Another question for you. Is there a cruise going this summer to continue monitoring this algae?
I'm actually not sure about that one. I would have to check into that for you, but yeah, I'm not sure. COVID has kind of changed a lot of things as far as cruises go. So I would definitely have to check into that, but I could get back to you on that if you wanted to know.
Looks like in the chat, there is a NOAA cruise that got approved today for a cruise in July.
There you go. Just today.
We'll give one more minute for questions, Danielle. All right, thank you so much, Danielle. We are going to take a quick 5-minute break before we begin our last presentation. Thank you everyone for waiting. Here with us today to give our final presentation for the afternoon and for our symposium is Shane Murphy, who is an undergraduate student at UH Hilo.
Alrighty, thanks for that introduction, Carmelita. Hi everybody, my name is Shane, and today I'll be presenting my senior undergraduate thesis research, which is comparing photochemical efficiency among Hawaiian coral species in a closed system aquarium. Next slide. So corals are important to research for their economic, ecological, and cultural value. Corals are foundational organisms, meaning that when corals are around, they can provide habitat that houses over 2 million marine species worldwide. As we know, climate change has been negatively impacting coral habitats severely in recent decades. One of these factors is global warming, which induces higher temperatures, causing coral stress and mortality. So the goal for us researchers is to find out what's driving the physiological mechanisms behind coral stress and mortality in order to hopefully mitigate the issue. Next slide. So corals exist in what's called a holobiont, and the aspect of this that my project focuses on is coral-algal symbiosis. This involves a mutualistic relationship where corals shelter algal cells and algal cells provide photosynthetic products to corals, which can be broken down for energy. So you might be familiar with the phenomenon known as coral bleaching. This actually occurs when the symbionts in coral tissues undergo photohell, or basically too much light in the environment, which overexcites them and causes them to produce toxic compounds, which the coral doesn't like, and it forces the coral to then expel the symbionts, turning that characteristic stark white color and becoming severely immunocompromised. So the algae in these coral tissues are typically of the family Symbiodiniaceae, which can be divided into many different genera, each of which have been well studied and are known to have different resistances to light and temperature stressors in the environment. There's also some amount of selectivity that happens here between the host and symbiont, where certain coral species are actually found to contain certain algal genera, which is why during something like a bleaching event, you might see some species survive just fine, while others tend to suffer much more. Next slide. So before getting too deep into my project, I wanted to detail some things about photosynthesis, and more specifically, what happens photochemically inside the pigments of these algal cells. So when light hits these pigments, it enters what's called photosystem 2. Once the light is in photosystem 2, there's one of three things that can happen to it. The first of which being photochemistry. So photochemistry is good. This is what we want. This is where light enters the complex and then is sent through the rest of the photochemical chain to produce those beneficial organic compounds for the coral host. Now, unfortunately, photochemistry often can't keep up with the amount of light that's in the environment. And this is what's known as light stress. And when this occurs, the symbiont has to actually release this extra light energy in the form of either fluorescence or in the form of heat. Next slide. So to measure fluorescence, we use what's called a pulse amplitude modulated, or PAM, fluorometer. And this is what you see pictured here in the upper right corner. If you look closely, you'll see a long gray cable with a metal tip on the end. And the way this works is essentially you press that cable tip right up against your sample. The instrument flashes a bright pulse of light and then measures how much light is actually emitted back into the sensor as fluorescence. If you look closely again, you'll see a black cable. This is what measures PAR, or basically the amount of light in the environment that is within the photosynthetic spectrum and can be used for photochemistry. So my project focuses on three main parameters, the first being FV over FM. This is the maximum quantum efficiency of photosystem 2, or in other terms, the maximum amount of light that can be held within the photosystem at a given moment. The next parameter is delta F over Fm prime, or the maximum photochemical efficiency of photosystem 2. Now this parameter is similar to FB over Fm, except it's measured in a lighted environment where we know things like fluorescence and non-photochemical quenching are occurring. And thus we know that this parameter can represent the maximum possible photochemical efficiency. Now the third parameter is NPQ, or non-photochemical quenching, and this is what represents that heat dissipation that I talked about earlier. So what we would expect is that as PAR increases in the environment, delta F over Fm prime will decrease and NPQ will increase as signs of light stress. Next slide. So the MOP Coral Propagation Project houses roughly 40 different coral fragments of 3 different species. This is a closed system aquarium, meaning that the water within it is constantly recycled through filters, and any nutrients, salinity, temperature, things like that are all controlled and maintained by the aquarium caretakers. Colonies within this aquarium were all collected from various locations around Hawaii Island, including shallow reef habitats in Hilo and Kona, as well as fragments that were rescued from anchoring and mooring line incidents in Kona, as well as fragments that were actually grown from pieces that were cut off from the original parent colonies. Next. So the previous literature is not super heavy into defining the light stress tolerance we could expect in these species, but there is some information regarding this. With Poecilopeira meandrina, we expect the species to show very high susceptibility to bleaching during a bleaching event. And this is thought to be because it typically contains algal symbionts that have a very low thermal tolerance. The species also has a high surface area branching morphology, meaning that it's able to take in a lot of light from the environment at any given time. Porites lobata is sort of the opposite, where it's been shown to have a very high stress tolerance during bleaching events. This could be because of its mounding and low surface area morphology. And then in Montipora capitata, we see quite a wide variability in its light tolerance, and this is thought to be because there's a wide variability in the symbiont communities in its tissues, as well as the species displays a wide morphological range. Next slide. So my research questions essentially are to compare each of these 3 parameters among the 3 coral species, and then to also determine if increased light exposure is related to changes in delta F over Fm prime or NBQ. Next slide. So to answer these questions, colonies were first chosen for sampling based on their morphological similarities and health. I really wanted samples that had a nice flat area where measurements could take place at a consistent angle, and also colonies that appeared healthy and had healthy pigment densities in their tissues. These colonies were also assigned number IDs and locations where repeated measurements could take place on the surface, and a special attachment was also placed on the tip of the fluorescence sensor, as you see pictured here, which helps to sort of maintain a consistent spacing and angle with each repeated measurement. Next slide. So light curves were conducted using the aquarium light sources, which are set to staged intensities that essentially start dim, increase in intensity throughout the day, and then dissipate until turning off to sort of mimic the approach and dissipation of peak solar radiation. So I took 2 sets of FV over FM measurements, once before sunrise and once after sunset, in order to quantify that parameter while photosystems were in a dark adapted state. I then repeated NPQ and delta F over Fm prime measurements every 3 hours throughout the day, measuring PARs simultaneously with each of those. Next slide. So this first figure shows our comparison of delta F over Fm prime among the 3 species using the aquarium as a light source. So on the x-axis, we have time, and on the y, we have delta F over Fm prime. Each of these box plots are color-coded by species, with box plots representing the median and interquartile ranges. So what we see here is that there were significant differences between different groups at different time points. However, this is very uncharacteristic light curve data. What you would expect to see is as PAR increases throughout the day, you'd see a drastic decline in delta F over Fm prime, followed by a drastic increase, leveling off to values similar to where they started before illumination. So something happened here, and looking further into my data, I found that these aquarium lights were actually producing little to no photosynthetically active radiation because these aquarium lights are actually old and expired. So this meant we were essentially raising shade adapted corals, and also meant that I needed to implement a new method of light curve in order to quantify photochemical efficiency. Next slide. So then a light curve was conducted using the PAM itself as a light source. This function includes 8 1-minute illumination periods, each of increased PAR intensity. And this is what you're seeing in these pictures on the right. The upper right image shows the lowest intensity, while the middle shows one of the middle intensities, and the last is the brightest intensity. So initial measurements of FV over FM were taken before illumination, and then subsequent measurements of delta F over Fm prime and NPQ were taken directly following each illumination period. Then more measurements of delta F over Fm prime and NPQ were taken during dark recovery over an interval of about 18 minutes after illumination. This provided for 15 total measurements, with 9 during illumination and 6 during dark recovery on 7 of each coral species. Next slide. So this first figure shows our comparison of FV over FM among species using this PAM light source. On the X, we have species, and on the Y, we have FV over FM. And these box plots represent the mean and standard error of the different species in this parameter. So what we see here is that MCAP and P meandrina were actually statistically similar, while Paredes lobata showed a much lower capacity for being able to hold light in its photosystem. Next slide. Now this figure shows our comparison of delta F over Fm prime among each species. On the x-axis, we have the time at which measurements were taken. On the left-hand Y, we have delta F over Fm prime, and on the right-hand Y, we have our PAR. So this dashed black line indicates the level of PAR in the environment, and each of these color-coded lines represent the mean values of delta F over Fm prime for each species. So what we see here is that for all species, as PAR in the environment increased, their photochemical efficiency decreased as well. And then once the light was shut off, we saw these values jump right back up and then eventually plateau back to where they were before illumination. What this also shows us is a clear stratification among the 3 species in this parameter, where Paredes lobata displayed the lowest photochemical efficiency, and P meandrina had the highest, with M capitata falling in between the 2. Next slide. Now this plot shows is similar to the last one, except showing NPQ on the left-hand y-axis. And again, we see a clear stratification here between species, and signs of light stress or increases in NPQ occurring with increases of light in the environment. Here we see that Paredes lobata had the highest values of NPQ across all time points. And then it's a little more interesting for M capitata and P meandrina. You actually see this unique crossover effect where M capitata was initially lower, but after a certain amount of time, it really shot up and surpassed P meandrina, and then quickly relaxed down faster than P meandrina was able to as well. Next slide. Now this plot shows the results of our linear regressions between delta F over Fm prime and PAR for both all data points combined and individual species. So on the X, we have our PAR, and on the Y, we have our delta F over Fm prime. And the thick black line indicates the regression conducted for all data points, while the color-coded lines represent the regressions for each individual species. So what we see here is that there were significant negative relationships between PAR and delta F over Fm prime for all 3 species, with, again, Paredes lobata showing the highest amount of light stress with the lowest photochemical efficiency, and P meandrina showing the highest values of efficiency, with M capitata falling in between the 2. Now, what you also notice is that the slope of the line for M capitata is much steeper than the other 2, meaning that this species stressed out much faster than the other 2 with increased levels of PAR. Next slide. Now, this figure is similar to the last, except this time showing NPQ on the y-axis. What we find here is that for all 3 species, there was actually a significant positive relationship between increased PAR and increased NPQ. So what this again shows us is Paredes lobata is exhibiting the highest signs of light stress with the highest amount of heat dissipation occurring at all values of PAR. And then again, generally we see P meandrina having the lowest levels, with M capitata falling in between the 2. Next slide. Now this plot shows the effect sizes that an increase of PAR had on values of delta F over Fm prime among the 3 species. So on the x-axis, we have this effect size, which represents the amount of change in this parameter we would expect to see with an increase in PAR by 1. And then on the y-axis, we have our species. So what this shows us is that M capitata actually had the most negative effect in delta F over Fm prime among the 3 species. Now you might be noticing these effect sizes are small, But when you consider that PAR typically increases on the scale of a few hundred at a time, and then also that values of delta F over Fm prime are typically between 0 and 1, if you were to multiply that effect size by a few hundred, that does denote a very significant effect here. So what we see is that Capitata tended to show the fastest rate of decrease in its photochemical efficiency, followed by Meandrina, and then followed by P. lobata. Next slide. Now this plot is similar to the last, except showing the effect of PAR on values of NPQ. And what we see here is Parietes lobata really outshadowing the other two species in terms of how affected it was by increases in PAR. The effect size here was roughly 0.0013, followed by M. capitata with the next highest effect, and then P. meandrina with the lowest. Next slide. So overall, in summary, we find that ranking these three species, P. meandrina appears to be the most overall photochemically efficient, followed by M. capitata, and then with Parietes lobata being the least efficient. This is indicated, just like I said, on a general ranking system, where I looked at the values for each of the three parameters and sort of compared where each of the species fell for each one. I also found a significant negative relationship between PAR and photochemical efficiency, and found a significant positive relationship between PAR and NPQ. Next slide. So these results do contrast from the literature and contrast my own hypotheses as well. I thought Parietes lobata would do the best and Poecilopora meandrina would do the worst with increased light. These findings were the opposite of that. So a possible explanation for this could be that skeletal diffraction might be a very efficient energy dissipation mechanism for some species. When I was taking these measurements on, say, a meandrina colony, it was very obvious that light was scattering deep into the colony skeleton more in this species than it was in the other two. This is what you're seeing here in these two pictures on the right. A bright pulse of light on meandrina tended to almost look like glowing from inside the colony, while something like M. capitata on the top right image glowed mostly just on the surface. So prior studies do show that skeletal morphology can be an important factor for determining differences in light stress among different coral species. And then another explanation could be that certain environmental factors like increased heat, reduced current flow, and pH can also sort of combine to worsen the effects of light stress. And none of those factors are really present in my controlled aquarium environment. Next slide. Next slide, please. Okay. Broader impacts of this research mainly include furthering our understanding of how we might expect some of the most common Hawaiian coral species to react to light stress. As global warming intensifies in the future, we expect that light exposure and light intensity in shallow reef environments will increase. And so we want to be able to predict which of these species we might be able to survive the best. As a future direction of this study, first and foremost, a tissue analysis should be conducted to reveal the different symbionts residing in each species, because this will then help us distinguish whether differences in photochemistry are due more to capabilities of the algal symbiont or due to things like skeletal diffraction or other environmental parameters. So this study should also be repeated with varying environmental parameters and also repeated in an actual reef habitat to compare how those results might differ from my results, which were conducted in a closed system aquarium. Next slide. I'd like to thank all of these people for their contributions to the project. And of course, thank you to TCBES for letting me present here today. Next slide. And thank you. I'll take any questions.
Thank you so much, Shane, for giving us a great ending presentation for today and our entire symposium. And if anyone has any questions for Shane, you can throw them in the question and answer box and we will get those to him. Okay, we have a question. What do you think will happen overall to these shade adapted corals if a stronger light source is introduced?
So that's actually the next goal in this project, in the MOP coral propagation project, is to install new lights. And I think what's going to have to be done is setting these at a low intensity initially to sort of let these corals adapt, and you really just see how they react to being in an actual lighted environment before subjecting them to like a full light exposure mimicking the actual approach of the sun.
Okay, we'll give our audience one more minute to see if they have any questions. All right, Shane, thank you so much for a great presentation.
Alrighty, thank you again.
All right, everyone, I'm going to turn it over now to Lisa Mason to give our final remarks.
Well, we have made it through our 2 days of our 2021 TCBES Symposium. Thanks for sticking with us. Great job to all of our presenters. We do want to let everyone know that we are giving out student presentation awards for the most outstanding presentations. So during each presentation, we had anonymous judges made up of TCBES and Hilo faculty and staff. We are currently in the process of compiling those scores, and we will be announcing the winners for this year's symposium this afternoon, and we will contact winners by email. We also are going to be releasing a press release to our community, so you can keep your eyes open for that. We will be awarding presentations to both graduates and undergraduates for 15-minute and 5-minute presentations each. You also get a chance to have your name added to our official TCBES Symposium plaque. Next slide. All right, and so again, we want to end our symposium with a big mahalo to everyone that was here with us who participated. Mahalo, Dr. Tracy Wegner and Dr. Rebecca Ostertag, for your support in putting together this symposium. We like to mahalo Halau Ohia for all of the amazing planning and thought and energy that went into our Koahu sessions earlier. Mahalo to our competition judges, to all participants and presenters, and to Hilo for allowing us to run this symposium from campus. You could visit the TCBES website for more information about the Masters in Science graduate program, weekly seminar information, and student news and updates. Thank you for attending, and see you next year. Aloha.